All right. Good afternoon. Good afternoon, everybody. Huh? Yeah, I'm gonna finish the statistics. Finish the statistics. Finish the probability. I will have a couple questions to do on the inequalities, and then we're gonna try and see if we can just do a paper one. What the paper one will do is that the paper. No, we've been doing paper twos. That's going to take a whole lot of time. Kind do either do a paper one and get a chance to touch all the topics on a paper one. Can't do a paper two. We basically did all the paper twos between over the last 4 days. So I think it makes sense to do a paper one and just get a chance to just touch all the topics again. You get me? All right, guys. So let's do this. So we're on the statistics yesterday. We got into 2018. We're working down to 2016. So I'm doing the past papers from 2022 down to 2016. All right. And so now we're on 2018. We completed 2019 yesterday. All right. And we're doing the statistics questions, as I said. So this is one on 2018 on the screen. But I can see the screen and hear me clearly?
Yes, sir.
All right, good. So this question says, the number of runs scored by a cricketer in 18 consecutive innings, I mean that these are 18 values here, is illustrated in the stem and leaf diagram. All right, that's it. And they give us a key. So for example, it means that this figure is 13, 1, 3, 13. Right? That's understood. It said determine the median. Now, if there are 18 values, initially it's going to divide 9 and 9. And so the median is going to be the average of the 9th value here and the 10th value here. The 9th and the 10th value. All right. So we need to find the 9th and the 10th value. Now we have to divide it half and half and then the average of the two middle ones. So it's 1, 2, 3, 4, 5, 6, 7, 8. This is the 9th value. That's the 9th value. And this is the 10th value. So if we're to divide it half and half, then basically this would be the first 9 values. And this will be the second 9 values. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so the median is the average of the two middle ones, which will be the average of these two. This one and this one will give us the median. All right, so remember the median is like you're adding a value to the data, Q2. You're adding a value to the data and you're averaging 19, because this 9 will be 19 and this 4 will be 24. So we're averaging 19 and 24 divided by 2. So we can write it here. Q2, the median Q2 is 19 plus 24 divided by 2. Somebody wrote that out for me, please. Have a calculator, Kai? Left it. Can somebody write that out, please?
21.5.
21.5. That's 21.5 runs, right? It's the number of runs. It's 21.5 runs. All right. Now, to find the quartiles, you have to come and work inside here. Remember now, these values now, these values that we have here, these values will form now a part of the bottom half and top half. So it is as if we added a value in between those values. And so this, all of these values is the bottom half. All of these values will be the top half. So if we're going to find the Q1, we'd have to find the median of the bottom half. If we're going to find Q2, we'd have to find the median of the top half. All right, that's how it is. So they want us to find the interquartile range. And that interquartile range is Q3 minus Q1. Q3 minus Q1 is that interquartile range. Come on. So let me say that again. Now that we have used these two values to find the median is as if we added a value to the data in between them. So all of these values now, including the 9 that we use to calculate this median, is a part of the bottom half. And this 4 is also a part of the bottom half, the top half. So if we want to find Q1, because we want the interquartile range done, so we need Q3 and Q1. We now have to find the median of all these values in the bottom half. So this will be the bottom half. And we need to find the median of all those values. How many values are there? There are 9 values there. And because there are 9 values there, the median is the 5th one. Like you're dividing it 4, let me use a different color. Like you're dividing the bottom half 4 and 4. And those values are above and below this 0. So this 0 becomes the Q1 value. Similarly, in this top half, this 4 is a part of your top half, even though you used it to calculate the median. The median, as I said, is like you added a value to the data because the number of data originally was an even number of data. And so, again, since there are 9 values there, you want to have 4. This is the top 4 in that half, and this is the bottom 4. And so the median of the bottom half is this. So that becomes your Q3. So this value is your Q1, and this value is your Q3. All right. So based on that, the Q3, if we go back to this now, the Q3 will be 31 minus the Q1 will be 10. 10, that will be 10. So it's 31 minus 10, which is now 21. 21 runs is your interquartile range. If they wanted the semi-interquartile range, we would divide this by 2. And basically that is it. All right. All right. Next thing they want us to do is to construct a box and whisker plot. So the box and whisker plot uses the smallest value and the quartiles and the largest value. So the smallest value here is 2 runs. Let's write down the values that I want to use. So it's 2 runs. The first quartile as calculated is 10. So we're going to go for 10. The median is 21.5. 21.5. The upper quartile is 31. 31. And the largest value is 47. 47 is the largest value. So your box and whisker plot would use those as your critical values in the box and whisker plot. These values in the middle will basically form the box, and you extend your whiskers out to there, or to those values. But it has to be a scaled drawing. Remember, a box and whisker plot is a scaled drawing. And we're going from 2. Remember, we're going from 2 all the way up to 47. So let's start a scale drawing. And let's say we start at 0, since we're going at 2, and we're going up to 47. So let's say that is 0, 10, 20, 30, 40, 50. Let's say that is it. So that's 10, 20, 30, 40, 50. All right. And we're going to put on the values now. So the first value we're putting on is at 2. So this will be about 5. So 2 will be maybe around here. All right. 2 will be around here. So we're going to put our start right here. So this is our 2. Now we need 10. 10 is clearly right here. So the first box line is 10 there. Then we need 21.5. So this is 20. 25 will be around here. 21 maybe is around here. 21.5 maybe is around here. Then we need 31. This is 30. So 31 maybe is around here. And that is your box. And the second whisker goes out to 47. And this is 45. 47 with maybe around here. And then you complete that whisker. And then I usually like to put the values on it. So I would put the 2, the 10, the sorry about this guy, sorry about this. 2, the 10, the 21.5, the 31, and the 47. That's what I would put. All right, and there's a comment on the shape. All right, comment on the shape. Now, if I look at it, the difference inside here is about 11.5. The difference inside here is about 10. So you say those are relatively equal. All right, so the boxes are relatively equal, slightly to the left. But if I look at the whiskers, this one is much longer than this one over here. All right, so since these boxes are relatively equal, but this one is much longer than this one, I'm gonna say it's skewed to the right. Why is it skewing to the right? Because remember, the number of values from here to here is the same number of values, you know, from the median to out here. There are 9 values out here, basically, you know, approximately, you know, and there are 9 values inside here as well. So you have 9 values spread out between 21.5 and 47, and you have 9 values spread out between 21.5 and 2. So you see that you have the values out here are more spread from the median, right? So I would say the data skews to the right, skews to the right, right? Skews to the right, because from the median to this whisker is longer than from the median to this whisker, because the boxes are relatively the same. All right, and that is how I would reason it out. All right, that is how I would reason it out. All right, so I'm gonna say it is skewed to the right. All right, so ask us to comment on the shape, skewed to the right or positive skewed, skewed to the right. Or you can say it is positively skewed or positive skewed. Yeah. Yeah. Positive skewed or positively skewed. All right. So you can say this or you can say this. All right. That finishes that question. Second part is a probability, which we're going to do after. Let's look at 2017. 2017. But okay with that question a while ago? But okay with that one?
Yes, sir.
Online, everybody okay with that? All right, good. All right. So here now we're going to look at 2017. We're looking for the statistics question. Well, this one is probability. All right. This one also. Oh, well, this one is statistics, right? This one is statistics. So let's do it. So this question says, the table shows 20 spindles, shows a length of 20 spindles, right? Prepared by a carpenter to build a railing for an existing staircase. Right? So these are the lengths of the spindles, and there are 20 of them. So there are even number of spindles. First thing I'm going to check is if they are in ascending order, which they are. They're in ascending order from here to here, and then it continues here to there. All right? So they are in ascending order. First 10 in this way, and the second 10 this way. All right? So the question is asking me for the mean length. Wow, what a question. The mean length is the sum of all these values divided by 20. You know? So the CSEC wants us to add up all these values, these 20 values, and divide by 20. I don't like questions like this because it's just unreasonable to me to have to add up 20 values. We just have to do it. Nobody have to do it, and there's 2 marks for it. So the mean length is equal to the sum of the values divided by the number of values. You have to add up these guys. So can somebody add up that for me, please? I won't even bother waste time. Just add up these and divide by 20. So the sum of the values, you add them up and you divide by 20. Right? So somebody can add this up for me in the meantime. Just add them up. This plus this plus this plus that. I think it's unreasonable to add up so many values, but you have to do it. Then I ask for the modal length. So the modal length is a length that occurs most frequently, and it's looking like this one. This is the only one that is repeated. 25.2 is the modal length. So I'm going to write 25.2, and the measurement is in centimeters, is it? Yes, I have to state that. In centimeters is the modal length. All right. The next one is to get the median length. So since there are 20 values, the median is going to be a value injected after add a value to the data. So it's a value between the 10th one, because this is the bottom half, you know. This is the first half of the data, and this is the second half of the data. All right. And so it is a value between these two. The average of those two will form the median. Remember, it's like you're adding a median, adding a value to the data. So it is the average of those two middle values would give you a median. Right? So the median is Q2, which is equal to 24.4 plus 25.2 divided by 2. That gives me the median length. So can somebody work that out, please? $434.7 and divide by the 20 now for me, please. Divide that by 20. 21.735, and you have to say centimeters. All right, that's the mean. All right, and work this out for me now to get the median. Get the median. I want everybody understanding now. Remember, when you use two values to calculate the median, work it out for me. 24.8 centimeters, right? So when you use two values from the data to calculate the median, it is as if you're adding another value to the data. You're adding a value to the data between these two. You're adding a value between them to the data. And therefore, these two values will remain in the bottom half and the top half. Right? They will remain in the bottom half and the top half. So it's as if we added another value to the data, which is the 24.8. So we added Q2 to the data, which is 24.8. You added it in between this bottom half and this top half. And so the bottom half is still all of these values, including the 24.4, and the top half includes the 25.2. When you have an odd number of values, then one of those values, the middle one, is your median. And so that median is no longer a part of the bottom half and the top half. The median is never a part of the top half and the bottom half. All right? So here now, when I ask us for the interquartile range, it is equal to, the interquartile range is equal to, sorry about that thing, I keep touching this thing. It's equal to Q3 minus Q1. So I need to calculate Q3 and I need to calculate Q1. So come back on the data. So let's go again. I'm going to erase these now because I already used them to calculate the median. So the median is there. So I want the median now of the bottom half, this bottom 10. So like I'm dividing it 5 and 5. And so the median of the bottom half is the average of these two middle ones. And the median of the top half is the average of these two middle ones. So these two will give me Q1. Average of them 11 plus 12.6 over 2. And these two will give me Q3, which is 29.1 plus 30.4 over 2. That's how we're going to get those quartiles. But understand that?
Yes,
Understand that? Good. So I'm going to copy this down. Well, can you tell me what this one works out to? Tell me what each one works out to. Let me shift this down a bit. Shift this.
So Q3 is 29.75.
All right, hold on. I'm going to shift this over. This one is what? 29.75?
Yes, sir.
And Q1 up here is what?
11.8.
It says 29.75 becomes 29.75. 29.75 minus 11.8. 11.8. And I work that out, and the answer is in centimeter. What is that? 29.75 minus 11.8. What that work out to?
So 17.95.
17.95 centimeters. And that becomes the interquartile range. If they wanted the semi-interquartile range, we'll divide this by 2, half of the interquartile range. All right. This one is a probability question, so we'll do it afterwards. Let's go to 2016. Let's go to 2016 now. 2016. We're gonna come back and do the probability right after. Probability questions. So we got 2016 now. Statistics on 2016. 2016 is right here. All right. So looking for the. All right. So this is a statistics question up here. All right. So this is it. It says, use the data provided. Use the data provided below to answer the questions that follow. So this is a set of data. It says construct a stem and leaf diagram to represent the data. Again, I want to ensure that the data is in ascending order, which we can see there. It's in ascending order, right? Send it this way again and then ascend that way, all right? So it goes like this. It goes from here to here first, is the first line of data, and then it continues here to there, and then here to here. Right? So the data is in ascending order. So we're looking for the stem values. Stem values start at 1 and end at 7, from 1 to 7. So I'm going to put in the stem values from 1 to 7. So it's 1, 2, 3, 4, 5, 6, 7, your stem values. Then you want your leaf values. You can do like that and write stem, leaf. All right. So the ones now, we're doing the ones. These are the ones. Are the tens, I should say. So it's 5, 6, 8, 8. It's kind of too large to me. 5, 6, 8, 8. Let's zoom it up. So it's 5, 5, 6, 5, 6, 8, 8. So we're doing the 20s. The 20s. So these are the 20s. All of these. A lot of 20s. These. All of these are 20s. So it's 20, 21, 22, 22 again, 22 again, 25, 28. Those are your 20s. They're going for the values in the 30s. So these are the 30s right here. Only 4 of them. So it's 30, 30 again, 32, 35. Then we're going for the 40s. So this is the first one and then this one. Those are only 2 40s. So it's 40 and 41. Then we're going for the 50s. These are the values in the 50s, those 3 values. So it's 52, 54, and 59. We're going for the 60s. These are the 60s, 3 of them. So it's 60, 65, 68. And then there's only 1 value in the 70s, 75. 75. And that is your stem and leaf diagram. But go to that. But okay?
Yes, sir.
All right. So how many values are there? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So there are 28 values there. So if it's 28 values there, you're gonna have to, if you want to find the median, you're gonna have to divide it 14 and 14. 14 and 14. And so to find the median, you're going to have to go to the 14th value, which is the last value here, 14th value, and the 15th value. Average them, and it's as if we're adding a value to the data Q2. And so all 14 values will be in your bottom half, and all 14 values up here will be in your top half, and the Q1 and the Q2. Just remember these things, guys. It's like you're adding the Q2 to the data, right? When the number of values is even. All right. 1, 2, 3, 4, 5, 6, 7, 8 by 3. That's 24. I know some of the divide is wrong. 8 by 3 is 24. So it's actually 12 and 12. And 14 and 14. 1, 2, 3, 4, 5, 6, 7, 8. 8, 3 is 24. So it's 24 values. So it's not 14 and 14. Let's correct this. This is actually 12 and 12. So it's 12 values and 12 values. And so we're going to the 12th value, 12th value, 12th value, and the 13th value. You average them to get the Q2. You're going to average the 12th and the 13th value to get the Q2. All right, if they ask for that, which they will. It says, state an advantage of the stem and leaf. The data is compact and the stem values are not repeated. Those are two examples, right? State an advantage. The data is compact, the stem values are not repeated. Let's write that. Stem values are not repeated. You have to repeat the stem values. That's one example. Another reason you could write is that the data is in a compact form. Data in a compact form. The data is presented in a compact form. Another one you could write is that the data shows the shape of the distribution. The data shows the shape of the distribution, or the stem and leaf diagram shows the shape of the distribution. Shows the shape, shows shape of the distribution. That's another reason. It's another advantage of this stem and leaves. Shape of distribution. Distribution. All right, it shows the shape of the distribution. So these are some advantages that you could write. All right, next one wants us to determine the mode. The mode is the score that occurred most frequently. All right, so look at it. I think this 2 is the most frequently occurring value. That 2 right there. This 2, which is really 22. 22 is the mode. Only that 2 occurs 3 times. So the mode is 22. You can see it in the data here. 22, 22, 22. It's the only value that appeared 3 times. 22. All right? 22. So the mode is 22. So the mode is 22. And then I want the median. I said the median is the average. It's going to be the average of the 12th and the 13th value. If you show it here, there are 24 values there. So I can take the first 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the first 12 is here. It's 12. And the second 12, I use a different color, is these. This is the second 12. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you divide it half and half. And then you want the average of 2 middle values. The last value in the first 12 and first value in the second 12. So you're averaging these 2 values, the 12th and the 13th, and circle them in black. this is the 12th value, and this is the 13th value. 12th and the 13th value. So the median, therefore, is the average of 30 and 30, which therefore is 30. Average of 30 and 30. All right, if you look at the table up here, you could find it again up here, the 12th and the 13th value. Look on the table, you could do it from the table as well. So you could find the 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the 12th value. That's the 13th value. So you see, same thing, 30 and 30. If you average 30 and 30, you're going to get 30. All right, so I'm going to write it down here that the median is 30 plus 30 over 2, which is equal to 30. Then we want the interquartile rate. And so we want Q3 minus Q1. That's what we want for the interquartile rate. Q3, look at this. Remember now, these two values that I've circled, they now form part of the top and the bottom half. They are part of it. And there are 12 values here. So you have to divide 6 and 6 again, and then find the middle value between the 6th and the 7th value. All right, so let me take off these two that gave us the median, take them off. All right, you want 6 values. Let me use a green to show it. 1, 2, 3, 4, 5, 6. And you're averaging the 6th and the 7th value. Those two you're gonna average. Right? These two. Those two be in the middle of the distribution. Right? Those two. Because then you're gonna have 1, 2, 3, 4, 5 values here. And 1, 2, 3, 4, 5 values there. So the Q3, sorry, is the average of these two values. That is Q3 would be equal to 52 plus 54 over 2. That is clearly 53. This is clearly 53. And then Q1 knows the same thing. You're going to divide this 6 and 6, and so it's the average of the 6th value and the 7th value. 1, 2, 3, 4, 5, 6. So you're averaging the 6th and the 7th value to get Q1. So if I mark it out here, it's going to be the Q1 is equal to that's 21. This value is 21 and 22 divided by 2. So this one is clearly 21.5. This is clearly 21.5. So it's 53 minus 21.5. Right? 53 minus 21.5. So I'm going to come down here and write it. This equals 53 minus 21.5. What is that equal to? What is that equal to? 53 minus 21 is 32 minus half, 31.5. That's correct? 31.5. And that's it. Any questions there? But okay?
Yes, sir.
You can leave these markings on the paper, you know, guys. But you make them faint. Use a pencil, for example. Put these markings on the paper. These are boxes, if you like. You can put them on there and leave them there. So the examiner see how you get your mark, how you get your values. You can, all right? You can do it. You can actually, you could actually divide it out on this. Because then this will be the bottom half. You have to use this. Your median will be right between these two values, right there. And so this will be your bottom half. And top half will be the rest of it down here. Top half would be these. Right? In the purple. That's to be a bottom half and a top half. And then you go for the median in the bottom half is Q1. The median in the top half is Q2. And remember this Q3, sorry. Remember Q2 is the value that you're adding in between here. In between 30 and the 30. It's like you're adding another 30 inside here between those two. But for your Q2. That is your Q2, your median. You're adding another value to the data. Because when you find a median, you must have an odd number of data. It's like you're adding the median to the data. All right, so that is that. So that finishes that, guys. We're gonna jump straight into the statistics. All right, we're gonna jump straight into the statistics, and we can actually start with this paper. But before I go into the statistics, you know, there are just one or two things I would want to see about statistics at this level. Let me see. Not statistics, probability. Sorry, probability. My mistake. Probability. Right. So there are one or two things I would just maybe say about it. And I can bring up another screen here before we get going. It's not allowing me to bring up another one. I open another file to do that. Open another file first. We'll open up another file. Right. So by now, normally statistics is at the basic level is the number of favorable outcome divided by the number of total possible outcomes. Right? Total probability can only be one. Total probability can only be one. The probability of if the probability of an event happening, for example, is X, then the probability of the event not happening, which is put with a prime up here, becomes 1 minus X. But the total probability can only be one. All right? Probability and sets are closely related. Probability and sets are closely related. And there's a probability formula that is related to a set formula that we can compare. And we're talking about when we have two finite sets, A and B. All right? And the formula goes that the probability, for example, of A union B plus the probability of A intersect B, make that a little smaller, is equal to the probability of A plus the probability of B. And so you can transpose and make any one of these subjects. I can take this one over here and subtract it. And I can take this one over here and subtract it. But this one is a union, it's an OR situation. So this one means everything in A and B. That's what this one means. This one means that. And this one is talking about just the intersection here. And it kind of makes sense, you know, kind of makes sense. So, you know, it kind of makes sense. If you want the intersection, it is like you're taking the A, where the A is everything, and you're taking the B. The B is also everything. And so you'll be adding inside here twice. And so to get, by adding inside here the intersection twice, to get the union, you have to subtract it out here, right? And so we have this probability formula. Remember now, we can transpose and make this is subject by subtracting that, or we can subtract this one. And the same thing goes for the number of elements in the sets. That's the first thing. Question will talk to us about independent events. Independent events. Now, independent events are events that they don't depend on each other. Independent events. And what happens in independent events? Independent events. The occurrence of one does not depend on the other. So in that case, the probability of both of them happening, A and B, becomes equal to the probability of A times the probability of B. That's something we need to know. Also, for independent events, the probability of A occurring, given that B has occurred, will be equal to the probability of A. Why? Because the A happening does not depend on B happening. So when events are independent, you end up getting this. All right. And why is this so? Why is this so? Because really and truly, this conditional probability, this is called a conditional probability. This is a conditional probability. What does it mean? What does it mean? Let me show you what it means. Conditional probability. It is like we have the set with A and B. A and B. And this is asking how much of A is inside of B. So like you take all of B first. And you're trying to find how much of A is inside of B. That's what this means, you know. How much of A is inside of B? How much of A is inside of B? That's what this means, a different color. That's what this conditional probability means. How much of A inside of B? So it's talking about this intersection. So if you were to write that as a formula, it means that the probability of A, given that B has occurred, is equal to the intersection, the probability of A and B. That's what the intersection is, you know. A and B occurring. This means A and B divided by the probability of B, because it represents that shaded region inside of B. So this is equal to this. And then now, how do we get this formula? How do we get this if the events are independent? It is because this intersection, right, or that and statement is equal to the product of these two, right? And so this will mean this if we make that substitution. If we replace this with the probability of A times the probability of B, and still divided that by the probability of B, then these will cancel each other. This will cancel that, and you're left having that the probability of A, given that B has occurred, is equal to the probability of A. All right, which means that the events are independent. So independent event, to show that independent events are independent, you need to show that this statement is true, or you need to show that this statement is true. If a question says two events are independent, then this statement is true, and also that statement is true. That's why independent events, one occurring does not depend on the other one occurring. That's independent events. Then we have what we call mutually exclusive events. So mutually exclusive events is quite simple. It means that there's no intersection, represented like this, two separate sets. There's no intersection, A and B. They are mutually exclusive. It means that the probability of A and B is equal to 0 when they are mutually exclusive. So if the probability of A and B equals 0, then they are mutually exclusive. It means that there's no intersection. Mutually exclusive events. Mutually exclusive events. All right, so that's what we need to do. If events are mutually exclusive, then the intersection is equal to 0. If probability are independent, then the intersection, probability of A and B is equal to probability of A times probability of B, or the conditional probability is equal to probability of A. A given B is equal to probability of A. Now let me explain this a little bit more with some numbers. I want to explain this conditional probability a little bit more using some numbers. Let's use some numbers to explain it a little bit more, because I think a lot of persons don't really understand it so clearly. So let's say I have some numbers. Let's have some numbers 1, 2, 3, 4, 5, 6, 7. All right, 1, 2, 3, 4, 5, 6, 7. How many values are there? 1, 2, 3, 4, 5, 6, 7 values are there, right? I'm going to write down two conditions, two probabilities. The probability of getting a 4 will be equal to 1 out of 7, because there's only one value there in 7, 1 out of 7. and the probability of getting a value greater than 3 would be all of these. No, not greater than or equal to 3. Well, yeah, greater than or equal to 3 would be all of these. All right? All of those. 1, 2, 3, 4, 5 of them. That would be 5 out of 7. 5 out of 7. All right? Now, what if I want the probability of getting a 4? And how would I write? The probability of getting a 4, given that I have a value greater than 3. So let me give these some letters. So let me give these some letters. So let's say event A is the probability of getting a 4, and event B is the probability of getting a value greater than 3. And if I want this now, the probability of A given B. What does this mean in terms of the statement up here? This really means that I want to know how many 4s, because the probability of A is getting a 4 now. How many 4 is in the set that I have with B? Now, this is a set that I have for B now. And I'm saying how many 4s are in it? There's only 1 4 in it. How many values are here? There are 5 values there now. 1, 2, 3, 4, 5. So I'm saying to you, the answer for this would simply be 1 over 5. That would be the answer now. 1 over 5. Because there's only 1 4 that is in those 5 values. That's what it means. This is asking me how many 4s are in the values that are greater than 3. And so it would be 1 over 5. If you use a formula to do this calculation, it would be that the probability of A given B is equal to the probability of A in, let me not go there. I just want to, let me not go there. I don't want to show that part. I just want us to understand the simplified version of it. And so the answer would be this, 1 over 5. How many 4s are in the values greater than 3? That's what this is asking. So that this becomes a base set. The B becomes a base set, and you want to know how much of the A condition is inside of the B. Right? So it's like you're taking the 4 out of only these values now. So it becomes 1 out of 5. So this will be your answer. 1 out of 5. All right? That will be your answer. I think that is enough for the explanation. I just wanted to give a little bit of explanation. I think I can get the rest of it when we're doing the questions. All right? And maybe doing the questions will clear up what I've been trying to say here a little bit more. All right? But remember this for the independent events, guys. This one, very important. And also remember this for the exclusive events. This one, for the mutually exclusive events. All right? And also remember this probability formula. This guy right here. This guy right here, probability formula. And most times, what it is, you'll have, for example, these 3, and you're trying to find this one. Or you might have these 3, and you're trying to find this one, and just transpose. All right, so let's look at the question. Let's look at the questions. All right, let's look at the question. So this question gives us, so it started the probability formula already. This question is a probability formula question. All right, because it gives us the probability of A, probability of B, and it gives us the union. And I want the intersection. It's quite easy. The intersection will be equal to the probability of A plus the probability of B minus the probability of the union. A union B. Simple as that. Comes a formula. All right? Simple as that. And so it will be equal to 0.5 plus 0.8 minus 0.9. That is the answer. What that equal to? 0.4. That's 0.4. That's correct?
Yes, sir.
Or I'll put another way, the sum of these two must be equal to the sum of this and this. That's another way to look at it. The sum of these two must be equal to the sum of these two. And if this is 0.9, they have to add 0.4 to this to get it equal to this one. All right, that's another way to look at it. All right, but that is the answer. So the probability of the intersection is 0.4. What's the probability of A given that B has occurred? We're going to use a formula for this. It becomes the probability of the intersection A intersect B. So it's how much of the intersection is in the probability of B. Remember, you know, this means if you have a set, if you have the sets A and B, this question is asking us how much of the A is inside of the B. The question is asking us for this region right here. What's the probability of this region inside of the B? That's what this means. How much of the A is inside of B? And so it is the intersection over B. All right, that's all that is. The intersection divided by B. And this works out to be equal to the intersection. Let's put on here. All right. It becomes equal to the intersection is 0.4 over the probability of B is 0.8. This is 0.8. And this works out to be 0.5. That works out to be 0.5. All right, that works out to be 0.5. And then it says no. State given a reason whether A and B are independent events. Yes, they are independent events. Why is that? Because this probability of A given that B has occurred is equal to the probability of A. 0.5 is the probability of A as well, and 0.5 is the probability of A. So we can say something like the probability of A given that B has occurred is 0.5. And the probability of A is also 0.5. Right? Therefore, the probability of A given that B has occurred is equal to the probability of A. Got them equal the same thing. And once you have this, it means that A and B are independent events. So that is how you can prove it. So you can say therefore, A and B are independent. You can finish it. Events, independent events. Just because it satisfies that condition. Another way you could show it is by showing, or we could prove it another way, by calculating the probability of A, given that the probability of B has occurred, we wrote that as 0.5. And then now we can multiply them and say the probability of A times the probability of B. If them two things are equal, then again they are independent. So we can work out the probability of A times the probability of B. Probability of A, remember, is 0.5. Probability of A is 0.5. So they'll be equality independent. Probability of A is 0.5. Probability of A is 0.5. Probability of this is 0.4. Independent events. Hold on, something gone AY right here. Probability of A given that is equal to that. And then multiply the probability of A times probability of B. So probability of A times probability of B. And that to be 0.5 times 0.8 is not much enough. All right, this is this part not much enough, but I know that this is correct. I'm missing something, but this part is correct. That proves that it is independent. But probability of A given that B has occurred is equal to probability of A. All right, that proves it. Because both of them equal 0.5. The condition was that 0.4 over 0.8 is 0.5. That works as 0.5. And the condition probability is equal to probability of A. probability of A is also 0.5. We're supposed to be able to prove it the other way as well, you know. Supposed to be able to prove it the other way as well. All right, I'm not seeing it right now. I'm not seeing it the other way, but this proves it, bro. This proves it. This proves it. All right, let's move to the next question. Now, this question says a bag contains 3 red balls, 4 black, and 3 yellow balls. 3 balls are drawn at random with replacement. So the total balls will come back to be the same each time. Find the probability that a ball, that the balls drawn are all of the same color. So you're gonna look at what are the possibilities. All right. So the possibilities are, I can actually list them down. The possibilities are that you can get 3 red, all of the same color. So you can get a red and a red and a red. You can write it like that. That means a red and a red and a red. Or, and when it's or, you gotta add the probability. This is an and situation, a red and a red and a red. When it's a red and a red and a red, it means that you have to multiply the probability of getting a first red, a second red, and a third red. Or it could be a green, a black, and a black, and a black. So let's put B, B, B. Or we could get a yellow and a yellow and a yellow. Yellow, a yellow, and a yellow. So those are the probabilities, the possibility that you want. What's the probability of getting a red and a red and a red? This is equal to. There are 3 initially there. How many total is there? The total there is 10. The total there is 10 initially. So probability of getting the first red is 3 out of 10. So that is 3 out of 10. So it is with replacement. So you're gonna place it, put it back in. The probability of getting another red is gonna be 3 out of 10 again, because you replaced it. 3 out of 10 again. Multiplied by, you're gonna get another 3 out of 10 because you replaced the ball, because it's with replacement. If it was without replacement, then this would reduce to 9 and this would reduce to 8. And also the red balls would also be reduced to 8. So this gives us the probability of getting a red and a red and a red. Then you have to add this one, add. Or I mean that you're adding the probability of getting a blue and a blue and a blue. So I'm put the plus on here. This is a plus. Plus. So if you work this one out, you're gonna get 27 over 1,000. I'm gonna put the plus over here. So the plus here is for this or. What are the probability of getting a blue and a blue and a blue? So the probability of getting a blue and a blue and a blue is equal to 4 out of 10. So it's 4 out of 10, but you replace it. So you got 4 out of 10 again, and you replace it. So you got 4 out of 10 again. So this works out to be 16, not 16. 4 times 4 times 4 is what? 4 times 4 is 64. 64. So that becomes 64 out of 1,000. So it's plus 64 out of 1,000. So this accounts for the or. Or, so you're gonna add again for this or. You're gonna get a yellow or and a yellow and a yellow. So it's 3 out of 10 again. So it's gonna be the same as this. 3 out of 10, and then 3 out of 10, and then 3 out of 10. So that becomes 27 out of 1,000. 1,000, 10 times 10 times 10. And you're adding these probabilities, because or means that you're gonna add them. So that becomes equal to when you add them. Adding 27, 64, and 27 over 1,000. What is that? All have the same denominator. What is that equal to?
So 118 over 1,000.
118 over 1,000, and that can be simplified down. What is it? 59 over 500. That's correct. That's correct.
Yes, sir.
All right. Okay, so that does that. All right. That does that question. And that finishes that one. I want to come back to this question afterwards, something is missing, but I don't want to toil on it. Because there's another way to prove this independent, right? But I'll come back to it if necessary. All right. Let's go to 2017. Let's go to 2017. 2017 is right here. All right. Not this paper. I don't want this paper. I want this one. And that's round, right? All right, let's look at this now. 2017. This question says a school cafeteria sells 20 patties, 20 chicken patties, so there's 20 chicken patties, 10 lentil patties, and 25 saltfish patties. So it's 20 chicken plus 10 lentil plus 25 saltfish. How many in total is that? That's 55. That's 55 total, right? 55 total. It says on a particular day, the first student ordered 2 patties but does not specify the type. It says the vendor randomly selects 2 patties. Calculate the probability that the first patty selected was saltfish. So there are 25 saltfish out of the 55 patties. So that one is easy. Probability of getting a saltfish, S for saltfish, is 25 of them out of 55 patties. Divided by 5, get 5 out of 11. But I give it that? But I go to that?
Yes, sir.
4 marks for that, you know. Can't believe it. 4 marks for that. Given that the first patty is saltfish, calculate the probability that the second patty is not saltfish. So the first patty is saltfish, right? If the first patty is saltfish, what are you gonna have left? You're gonna have 20 chicken patties left. You're gonna have 10 lentil patties left, and you're gonna have 24 saltfish patties left. That's what they're gonna have left if the first one is a saltfish. So when you go back to choose the second one, this is what you're choosing from now, which is now 54 patties you're choosing from now. So the probability of getting now one that is not saltfish means that you want these. So it's going to be 30 out of 54, the probability of not getting a saltfish on the second try. So on the second try, or on the second selection, the probability of not saltfish, I'm going to put the prime on it, becomes 30 out of 54. That is what it becomes. Divide that 2 by 2, or divide that 2 by what, 3. Simplify this down for me. What do we get? What do we get when we simplify this down? Carry calculator. Put in and get the lowest terms for me. Everybody understand this calculation?
Yes, sir.
All right. So this is the not saltfish are these 30 out of 54. Eh? 5 and 9? Yeah, 5 and 9. All right. So that one finished. That one finished. All right. So this was very easy. Straightforward. Can read that that's all that there was for this paper. All right, let's go to 2018. 2018 and see what happens. 2018. That question is on my mind. I'm gonna come back to it in the break. All right, 2018. So I want to do the probability. All right, this is a probability question. Looks like they're gonna ask for probability 3. It says insecticides A, B, or C are applied to lots Q, R, or S and S. Right? A, B, R, C are applied to these lots. It said the same crop is planted on each lot, and the lots are the same size. The probability that a group of farmers will select A, B, or C are 40%, 25%, or 35% respectively. So the 40% is 0.4, 25% is 0.25, 35% is 0.35. That's the probability of selecting them. So the probability of not selecting A is 60%. Probability of not selecting B is 75%. Probability of not selecting C is 65%. That's either you select it or you don't select it. So the probability that insecticide A is successful is 0.8. So the probability that it is not successful is 0.2. The probability that B is successful is 0.65. So probability that it is not successful is 0.35. Probability that C is successful is 0.95. So probability that C is not successful is 0.05. Illustrate information on a tree diagram to show all the possibilities on all the branches. All right, so the insecticides are A, B, and C to begin with. So let's say we're gonna start with a selection. So start with a selection of either A, let's be the A channel, the B channel, and the C channel. All right, A, B, or C. All right, So the probability of choosing a A, B, or C. All right, starting here. Make it shorter. A, I'm gonna come here for B, come here for C. So probability of choosing A is 0.4. 0.4. That's channel for choosing A. I'm gonna put A on this channel. Probability of choosing B is 0.25. 0.25. I'm gonna make this be the B channel. So that's probability of choosing A right here. Probability of choosing B right here. Probability of choosing C is 0.35. Probability of choosing 0.35. So we're not interested in not choosing, right? We're not interested in not choosing. If you choose A, is either it is successful or it is not successful. Let's say if this successful for A is 0.8, so I'm gonna put successful on top here. So A successful is 0.8. I'm gonna put that S for successful. This is 0.8, and this is A successful. And 0.2 if A is not successful. So I'm gonna put 0.2. 0.2 if it is not successful. I'm gonna put S prime. Or if it is not successful. So this is A not successful because I'm on the A branch. This is A successful because I'm on the A branch. All right. On the B branch now, it is either it is successful or it is not successful on the B branch. So right here is B. I'm on the B branch. So if B is successful, it is 0.65. 0.65. I'm going to put 0.65 here. And so if B is not successful, it's going to be 0.35. This is B not successful. I'm going to put S prime. B not successful. And then now the C. Okay, let me draw this a little bit more down like this. Just to give us some more space. This is a C channel. And is either C is not successful or not successful. Successful or not successful. So the C had a probability of 0.35 for selection. So this is 0.35. And if C is successful, it will have a probability of 0.95. 0.95 that it is successful. And not successful, C has a probability therefore 0.05. 0.05. This is not successful. All right, so we can work them out. So up here is A successful. A successful, you multiply these to get the value. A is successful. Can somebody multiply them out for me, please? Let me multiply them out. Let me go my calculator and multiply them out. We have to complete the tree and see what the conclusion is on each branch. All right, so multiplying these two values. So You choose A and it is successful, you multiply them. That's what the AS stands for, the probability of AS. So that's 0.4 times 0.8. 0.4 times 0.8, that's 0.16. That's correct? No, man, that's not correct. 0.8, 0.32. Yeah, 2 decimal places. Then you choose A and it is not successful. That's what this is. A is not successful. That's what this channel is. So it's like you choose A and you're not successful. So you're multiplying those. So I'm multiplying by 0.2 now. I'm getting 0.08. So here is equal to 0.08. And then here now you choose B and it is successful. So I'm going to write that as this. B successful. BS. B successful. So that becomes 0.25 times 0.65. That's 0.1625. 0.1625. And then here now is where you choose B and it is not successful. So I'm going to write B not successful. B not successful. B and S prime not successful. I'm multiplying these two. 0.525 times 0.35. 35. That's 0.0875. And I choose C and it is successful. So I'm going to write CS for this, meaning that I choose C and it is successful. So I'm now multiplying the 0.35 and the 0.95. So 0.35 times 0.95, that's 0.3325. And then I choose C and it is not successful. So that's C not successful. And I'm multiplying these two now. C and it is not successful. So I'm multiplying that by 0.05. I'm getting 0.0175. That's our probability tree, guys. But to go to that, that's not the only way to present it, but this way is good enough. But to go to that, let me show you the probability on each channel. Show the probability on each channel. All right. It says an insecticide is chosen at random. Determine probability that it is unsuccessful. So the unsuccessful ones. So it is either you choose A and it is unsuccessful, or you choose B and it is unsuccessful, or you choose C and it is unsuccessful. So to get that probability of choosing an insecticide randomly that is unsuccessful is one of those three. So I can say this probability that I want is equal to A unsuccessful or B unsuccessful or C unsuccessful, which basically becomes the probability. This one, the R means plus. The R means plus. The R means you're gonna add the probabilities, plus, plus. So you add this probability to this probability to this probability, you're adding them. All right, so basically you're adding those probabilities. So this becomes equal to the 0.08 plus the 0.0875 plus 0.0175. That's where you get there. Probability that you don't have any success. So it's either you choose the A that is unsuccessful, or you choose the B that is unsuccessful, or you choose the C that is unsuccessful. And when it is an or, you add the probability. So you add them up. So all you have to do is add those values and we're good. Add those probabilities down here and we get the answer. So it is 0.08 plus 0.0875 plus 0.0175. So the probability of getting an unsuccessful, randomly selecting an unsuccessful insecticide is 0.1825. If you want the probability for success, to choose one that is successful, then you would add these three, the successful ones. You would add them. All right, it's as simple as that. And that is there. That is the answer for that one. But go do that. But okay?
Yes, sir.
All right. So this question says no. A regular five-sided die, a regular six-sided die, sorry. A regular six-sided die is tossed 2 times. So if a six-sided die, the probability of getting any number is 1 out of 6. 1 out of 6 probability of getting any value. It says calculate the probability of obtaining a 5 on the second toss. Given that we obtain a 5 on the first toss. All right, give that obtain a 5 on the first toss. Let's set up this way. Let A be equal to the probability of getting a 5 first on the first toss. That's going to be 1 over 6, you know. 1 out of 6. All right, and if B is the probability of getting a 5 on the second toss, that is still 1 over 6. That is still 1 over 6. All right. So this is asking us for a conditional probability. It's asking us this: the probability of getting a A or it's B given A. It says B given A, getting a 5 on the second toss, given that we got a 5 on the first toss. So this is asking us this: B given A. That's what this is asking us. So this is actually equal to the probability of A intersect B over the probability of A. That's the formula for that. What's the probability of getting a A? Probability of getting a 5 and then getting a 5. It becomes equal to the probability of getting a A. Probability of A times the probability of B over probability of A right here, which in essence, if you calculate it, but independent events, it still works out to be equal to the probability of B, which is still equal to 1 over 6. That is the answer, because they are independent events. Getting a 5 on the second toss is totally independent of what you got on the first toss. So if you get a 5 on the first toss, getting a 5 on the second toss has nothing to do with the fact that you get a 5 on the first toss, because you're tossing them independently, and they're independent events. All right. So you could actually work the maths here: 1 over 6 times 1 over 6 divided by 1 over 6. They will cancel and give us 1 over 6 anyway. So that is the answer right there, 1 over 6. All right. And here now it says term probability of getting a 5 on both tosses. So the probability of getting a 5 on both tosses. So basically, this is asking you for the probability of getting of A and B. A and B. So a 5 on both tosses. So the probability of getting a 5 on both tosses becomes the probability of A times the probability of B, which becomes 1 over 6 times 1 over 6, which therefore is 1 over 36. 1 over 36. That is it. Another way to look at this, guys, is that when you toss the dice 2 times, is the same as tossing the 2 dice together, And you want to get here now. You want to see what double values you can get. What double values you can get. So you're getting a 5 on both tosses. So like you getting like it's the same as tossing 2 dice simultaneously, and you're getting 2 values coming up. So if that is the case, then you basically have a sample space of 6 by 6 possibilities, and you're pairing them 6 by 6 pairs, which is 36 pairs you're getting. 36 pairs of values you can get. And the 5 and 5 only appears once in those 36 tosses, in those 36 possibilities. So the answer could be viewed again as one out of the 36 possibilities. 1 out of the 36 possibilities if you would use a sample space approach. But this is the answer, 1 over 36. 1 over 36. All right, that is the answer for that one. 1 over 36. 1 over 36. And here now says, explain why the answer in C2 and C1 are different. Why are they different? So in C2, you're looking at a combined probability. In C1, you're looking at individual probabilities, and they are independent, right? So I'm saying in C2 down here, when you want both tosses to be 5, it's a combined thing. It's a combined probability. But up here, you're looking at getting 2 separate tosses, which are independent of each other. So I would say in 1, the events are independent. Two independent events. The events are separate and independent. And then in part 2, we have combined events. Events are combined. Producing the combined events producing a larger sample space. Combined events producing a larger sample space. Producing a larger sample space, and that's how we get it out of 36, out of a larger sample space. So you want to say that up here, you have separate events happening. You toss the first toss and then you toss a second toss. Here now, you want the 5 on both tosses. So it's a combined event. All right, and you want to say that in the first case, the events are independent. They are independent events in the first case. All right, I think if you say that they are independent events in the first case, you get your 1 mark. I think that is sufficient. Might I go to that?
Yes, sir.
All right. Let's go to what? 20, working our way down. Working our way up to 2019 next, right? 2019. Let's look at 2019. 2019. We're working our way up. All right. Okay. All right. So we didn't do this one yet. This question says a vendor has 5 apples in a tray, 5 red, 6 green, 4 yellow. So let's write that out. 5 red plus 6 green plus 4 yellow. That's a total of 15. Total of 15. A customer requests 3 apples but does not specify a color. Determine the probability that the apples chosen contain 1 of each color. All right. So they're gonna choose the 3 apples, right? And when they take out the apples, a vendor selling, Once a vendor selling, we have to say, okay, when they choose the apple, they're not going to replace the apple. So there's a situation where you're choosing without replacement. So what are the possibilities? We want 3 different colors. Let's look at the possibilities. And the 3 different colors are going to produce the same probability. Look, because you're doing it without replacement, right? So it's like one possibility, let's list them out here. You can get a red, 3 different colors you want, So you really want to get a red, a green, and a yellow. Or it could be a red, a yellow, and a green. That's the order in which you can select them. But you could get the green first. So it could be that you get the green, then the red, then the yellow. Or you could get the green, then the yellow, then the red. But then you could get the yellow first. So it could be the yellow, then the red, then the green. Or it could be the yellow, then the green, then the red. So these are all or situation, or. These are all the possibilities. Or. So there are 6 possibilities. 1, 2, 3, 4, 5, 6. So basically, I want to work on the probability for each of them, and then you can add them. But I can show that each of these will give you the same probability because you have replacement. So if we look at the first one, I'm not going to simplify it for you and show that each of them is going to give you the same. So if we look at the first one, remember, we're not replacing, If you take out the red first, the probability of getting a red first is 5 out of 15. Then you want a green, so you multiply. And then you get a green, so you multiply. So you're going to have 14 left to take out of, but there are now 6 greens. 6 greens. 14, you're taking 6 out of 14. Then you're going to have 13 left to get the yellow. You have 13 left, but you're going to get 4 yellows. So it's 4 out of 13. So what you know is that each time you take out one, this number is reducing. But the numbers on the numerator will all remain the same because you keep going for a different color. So if you look at this one, for example, you start with the red again. So again, this is 5 out of 15. Then you're going to go for the yellow, but you have 14 left. But you still have the 4 yellow there, so it's 4 out of 14. And then you're going to go for the green, but it's 13 left. And there are 6 greens. 6 greens. So you see that 3 numbers up here remain the same. And the 3 numbers on the denominator remain the same. Any one of these you go for, the probability is going to be the same because you're going for each color one time and you're not replacing it. So the numbers on the denominator will always be 15, 14, 13. And the numbers on the numerator will always be 5, 6, and 4. If I try this one and show you this one, the last one, if I go for the yellow first, it's going to be 4 out of 15. And then multiply, I'm going to go out of 14 now because I took out the yellow already. I still have the 6 greens left, so the 6 must be used. And then I'm going to go for the red, and there's a 5 red there still, but I'm now taking out of 13, and there's a 5 red. So you just get the same number up there. So anyway you take it, it's going to be 6 possibilities. 1, 2, 3, 4, 5, 6 possibilities. So the probability becomes 6 times each of these. Each of them is the same. So it becomes 6 times 5 times 4 times 5 times 6. 5 times 6 times 4 over 15 times 14 times 13. But understand that? Because
yes,
all
sir.
means that you're adding each of them. Good. So let's work this out, and that's the answer. 6 times the same probability for all the possibilities. 6 of them, and all of them giving the same probability. All these combinations giving the same probability. So 6 of them, and you're adding the probabilities. Because it's red, yellow, red, green, or yellow. I explained that already. Work this out for me, please. What I work out. Can I work that out for me? What is that? Huh? Huh? 4 and 91 is the answer. Everybody's get that? So this is going to give it the same, that's going to give it the same, and it's going to give it the same. They all give it the same thing. All of them give it the same thing. All 6. All 6 possibilities will be the same. But go okay with that? But good?
Yes, sir.
Yes.
Then we want the probability of getting all the same color. All the same color. Remember now, we're not replacing it now. So this now is that it's gonna be red, red, and red, or green, 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 or yellow, yellow, yellow. Remember, this is an AND situation, so you multiply. The or between here means that you're adding. Let's do the red, red, red. Remember, you're not replacing it now. So first you have 5 reds out of the 14, and then you can get 4 reds out of 13, and then you can get 3 reds out of, no, start at 15, sorry, 15, 15, 14, 13. So it's 15 first, 5 out of 15. So one of the red come out, you have 4 red left, but you still have 14 to choose from. And then you have 3 reds left to choose from 13. So that's the this is the probability of getting a red, then a red, then a red. Then you're gonna add, the or means that they're gonna add the probability of getting a green, and a green, and a green. So you start out with 6 green out of the 15. Then you take out one, you're gonna have 5 green left out of 14. That one gone, so you're gonna have 4 greens left out of 13. Or the possibility of getting a yellow and a yellow and a yellow. So if you start with a yellow, you're gonna get 4 out of 15 first. And then you're gonna have 3 left out of 14. And then we're gonna have 2 left out of 13. And then you add up those. So you're gonna work this out, add it to this, and add it to that. If you notice, all the denominator is the same, 15, 14, 13. But the numerator are different for each one. All right? Can somebody work that out for me, please? I'm gonna work it out myself. So this is 20 times 3, that's 60. Let's work out the 15. 15 times 14 times 13 is what? 2730 in all cases. But this becomes 60. Right? 5 times 4 times 3, that's 60. Plus, then work out this one, which is 6 times 5 times 4, that's 120 over the same 2730, plus this 4 times 3 times, that's 24, right? 24 over the same 2730. And you're adding this to this to this, so you're adding the numerator values. So this becomes equal to, adding the numerator values is 60 plus 120 plus 24. That's 204 over 2730. And you can simplify down to the lowest terms. 204 over 2730. And I would get equal to 334 over 455. That is the answer. That is it. What to go with that? What okay?
Yes, sir.
All right, let's look at 2020. Let's look at not 2020, 2021. 2021. 2021 is right here. 2021. All right. Let's look at this one now. Probability. All right, starts up here. This question says, 2 fair tetrahedral die which faces 1 to 4 are rolled. So they're rolling 2 die at the same time, right? 2 die. The numbers obtained on the turn down face of each die is noted. Each dice is noted. All right. It says, create a sample space to show all the possibilities for the 2 dice. All right, all the possible outcomes for the 2 dice. All right, so it's a four-sided die. So we're gonna create the sample space. So I'm gonna put the 4 possibilities for one of the die on the top here. I'm gonna cross it with the 4th possibility for the other die down here. The other die is down here. And we're doing the pairings. We want the pairings. So let me just go like so. And go like so. I want to show the pairings, right? That we can have in the sample space there. What are the possible pairs? Let me put them in red. So I can get a 1 and a 1. Let's say we're reading it this way down, right? So we're gonna say like this is one die and we're reading it with the other die, pairing it down that way. So it's a 1 and a 1, a 1 and a 2, a 1 and a 3, or a 1 and a 4. We can get a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4. We can get a 3 and a 1, a 3 and a 2, a 3 and a 3, or a 3 and a 4. Then we can get a 4 and a 1, a 4 and a 2, a 4 and a 3, a 4 and a 4. That's your sample space for the pairs. All right. So these numbers are the two numbers and the 2 die. That's your sample space. How many values there? 16. 4 by 4 is 16. So your sample space is 16. So any pair of values they want to get is going to be out of 16. So for example, you want the probability of getting a 2 and a 2 is going to be 1 out of 16 to get a 2 and a 2. 1 out of 16. All right? 1 out of 16, because that's only 2, 2. What's the probability of getting a 1 and a 4? A 1 and a 4, this and this, see? It don't matter the order, you know. Probability of getting a 4 and a 1 is 2 out of 16. I can get a 1 and a 4 or a 4 and a 1. So it's 2 out of 16 to get a 1 and a 4 on the dice, right? So it don't matter the order. So that will be 2 out of 16. But anyway, let's continue. That's the sample space. Then it says, using your sample space, use your sample space table created in A or otherwise. Determine probability of getting a 4 on both dice. I want to get a 4 on both dice. 4 on both. So this means a 4 and a 4 now. I want a 4 on both dice. That's what that means. So look at there. This is the only 4, 4 right here. That's 1 out of 16. 1 over 16. Easy as that. 1 over 16. 1 over 16. It's probability of getting a 4 on both dice. Easy. Probability of getting at least, getting a 4, so getting a 4 on at least 1 dice. At least 1 dice means at least 1 dice means you can get it on 1 dice or on both dice. So this means, you know, this means on one or both. That's what this means. It means getting on one or both. That's what this means. So basically, we're looking for all the 4s that we get. That's what this means. All the 4s that we ever get. We want to see all the 4s on at least 1 dice. Let's look at it. All the 4s that we get. So all the 4s are here. See them here, so these are all the 4s. These are all the 4s. How many of them? 1, 2, 3, 4, 5, 6, 7. So it's 7 out of 16 at the number. To get a 4 on at least 1 dice. That's 7 out of 16. 7 out of 16. So that is 7 out of 16. So the answer is just simply 7 out of 16. See, just one mark for it, and I can see it. to get a 4 on exactly one dice. On exactly one dice. That's 6 out of 16, you know. Because that's 7 out of 16 here, including the one that we got the 4 and the 4. So that is 6 out of 16. So look back at the diagram up here. Is these one dice. 1, 2, 3, 4, 5, 6. That's getting a 4 on exactly one dice. That's 6 out of 16. All right? So that's 6 out of 16. So let's mark that. That's 6 out of 16. And that can be reduced to 3 out of 8. Carry down to simplest terms. 3 out of 8. But good so far?
Yes,
But
sir.
okay so far? Good. Show that obtaining a 4 on both dice is an independent event. I don't like this question. This question kind of ambiguous. Because we're talking about, I say, getting a 4 on both dice. Based on our diagram. This is one event, you know. This is one event. Based on our sample space up here. They're talking about this event. And usually, when you talk about independent events, it's usually you're comparing 2 different events. Right? Usually you're comparing 2 different events. But I'm interpreting this to mean getting a 4 on one dice and getting a 4 on the other dice. That's what this means. I'm interpreting this to mean them separately. Getting a 4 on both dice. Show that they are independent events. All right? So if they are independent events, then we know getting a 4 on both dice. Independent events. So it means that probability of getting, all right, let's set up this way again. Let A be the probability of getting a 4 on the first dice. Let's call it 4-1 in first dice. And that is equal to 1 over 4. And let B be the probability of getting a 4 on the second dice. It is also 1 over 4. 1 over 4. All right? So the probability of getting a 4 on the first and a 4 on the second, we already worked that out as 1 over 16, you know. We already worked it out as 1 over 16. That is getting a 4 and a 4. We already worked it out as getting at 1 over 16 up here. See it here? Getting a 4 and a 4, a 4 and a 4. 4 on the first one and 4 on the second one. Right? Now, if this independent, if the events are independent, right? Then we can calculate now the probability of getting a 4 on the first dice, multiplied by the probability of getting a 4 on the second dice, which is A times B, A and B, which is equal to 1 over 4 times 1 over 4, which is equal to 1 over 16. So it's because this equals this, it means that the events are independent. So we can write it here. Let's put it in this. I mean, should I write it smaller, but let's put it inside this. Let's put it inside this. So we can say since probability of A intersect B is equal to probability. Oh, that's a mistake I was making on a question prior. This is the other way to get independent events. The intersection is equal to the probability of A times the probability of B. Because this is 1 over 16 from earlier, probability of getting both of them. That's what this is, A and B. And it's equal to probability of 1 over 4 times 1 over 4, them equal. That is why them independent. So since the probability of A intersect B is equal to the probability of A times probability of B, means that they are independent events. Therefore, A are in A and B. A and B are independent. We will call A the event of getting a 4 on the first die, and B you call the event of getting a 4 on the second die. 1 means first and 2 means second. All right? So they are independent. Independent. You have to spell it all for my guys, right? Independent events. That is it. By showing this, it means that we show that they are independent events. I think that the question that we're doing before, this is what we need to show. And this just kind of escape me a little bit. So independent event can be shown two ways. Show that the probability of A intersect B equal the probability of A times the probability of B. Or you can show the conditional probability, the probability of A given B is equal to probability of A. That's two ways you can show independent events, either this way or this way. So that's what I explained in the beginning. Let me see, that's what I explained at the beginning. Let's make sure, right here. All right, that's it. Yes, that's it. Two ways to show independent events. All right, so it escaped me a little bit in the first question, so I can go back to it. All right, that's how we show independent events. So by showing that they are independent, by showing that the 1/16 is equal to, if you multiply them individually, still equal to 1/16, then it means that the events are independent. But understand that once it asks to show that events are independent, you want to show either this or this. One of the two. And based on the values that we have, this is the one that we want to use, because it asks us for this in the beginning, 4 and 4. And independently, probably I'm getting a 4 and 1 is 1/4, and a 4 and the other one is also 1/4. And we already showed from the sample space that getting a 4 and both was 1/16 that was showed initially. And so that is why the events are independent, because it satisfies this rule, satisfies that rule for independent events. All right, look at this one now. This one now says, I'm going to get it from the diagram. It says, determine the probability of obtaining a 4 on both dice, given that a 4 was obtained on at least one dice. You know what this means? What this means, is how much of this is inside of this. Right? That's what this is asking. This is asking us. This is so the probability of getting a 4, probability of getting a 4, probability of getting a 4 and at least one dice. They want us to get the probability of getting this. So we want to know how much of this is in that. That's what we're trying to find. How much of this, how much of the 4/4 is in getting a 4 on at least one dice. Let me show that on the diagram now. That's what this probability is asking us. What's the probability of getting a 4 on both dice, given that we have a 4 on at least one dice? In other words, how many double 4 we get inside the set of values of at least one dice? Let me show you on the diagram what that means now. So we're going to put this as your base set. That becomes the base of your probability now, the base of your set. A 4 on at least one dice. They want to know how many double 4s are in that. That's what they're asking. So let's look at it on the diagram. So all of this, let me mark it a different color. All of this around here represents getting a 4 on at least one dice. All of that. That's what that is. Getting a 4 on at least one dice. How many double 4s are in there on both dices? How many double 4 are in there? This is the only both inside of that. So that probability basically becomes 1 out of what? 7, 1, 2, 3, 4, 5, 6, 7. Becomes 1 out of 7. That's what the answer is now. 1 out of 7. Only one both you can get out of the ones where you have at least one dice. So the at least one dice becomes like the base of what you're taking the double dice out of. So the answer for that is 1 out of 7. But you understand that? You can understand that, guys?
Yes,
in
sir.
purple is a set containing at least one dice. And in that set containing at least one dice, this is the only occasion where you have a 4 on both dice. So therefore, the probability of getting a 4 on both dice, given that you have at least one dice. It's when I say given that you have at least one dice, it means that you want to take the the two dice, you want to take the both dice event out of the event of getting at least one dice. So here is the base event. And you want to see how much of this is inside of that base event. Only 1 out of the 7. So the answer is 1 out of 7. Hope you can understand that. I hope you can understand that. That's the reasoning way to do it. That's the reasoning way to do it. But it also can be calculated. So it's 1 over 7 based on what I just showed you, right? So the answer is just 1 out of 7 down here. 1 out of 7. 1 over 7 is the answer. What's about one calculate it? The answer is 1 over 7. That's 1 over 4. 1 over 7. So it's like if I were to set it up and let this be event A in blue, and this up here be event B in red. I want to calculate it, right? Then we'll be calculating the probability of a B given an A. B given an A. That's what we're asking, you know. Right? I don't even want to explain it anymore. I might complicate with the numbers. Because sometimes probability can be kind of abstract, you know. I think this is the easy way to just understand it. It's how much of the double dice is in the set of at least one dice. As simple as that, because we had the sample space. Because we had the sample space working. Right? We had the sample space working. Right? Getting a B on both dice was this. Here. So basically this out of this. You can look at it that way as well. That out of that. That out of that. So dividing this by this. I look at it that way as well. Alright? So the prefer to get it from the diagram and understand that how much of the double force is in the set of the ones having force. 1 out of 7. 1 out of 7. Alright? But go with that. But okay with that? If you're using the probability, then it's this out of this. How much of this is in this? 1 over 6 over 7 over 7 over 16. 1 over 16 over 7 over 16. Which will become 1 over 16. 1 over 16 times 16 over 7. And these cancel, so you get 1 over 7 just the same. I don't want to use the calculation to show it when you cannot show it. There's a way for us to understand the what the conditional probability really means. It's how much of a favorable outcome out of a portion of the overall thing. And the portion of overall thing that we're taking it out of was the at least 1/4, at least 1/4, which is basically all of these around the corner here. These are at least 1/4. And the only double 4 in it was this. So it's 1 out of 7. That's the way to look at it. All right, let's not complicate it anymore. The answer is 1 over 7. Let's not complicate it. Answer is 1 over 7. 1 over 7. 1 out of 7 is the answer. All right, that is that. Let's look at 2022. 2022. 2022 is right here. And then the specimen, I know can take a break. All right. So a lot of the times, probability questions can be done using sets. Okay. And this one is a sets one. And the probability question just using sets and so whenever you have the opportunity to represent probabilities on a set diagram, on a Venn diagram, you can do it. All right? You can actually do it. This question says, at a school cafeteria, 80% of the students, S, so see here, these are the students, S, purchase chips, C, right? 80% of the students purchase chips. I'm going to put the 80%, right? I'm going to represent percentages on my Venn diagram. You can represent the Venn diagram for anything. You can use the actual values on the Venn diagram. You can use percentages on the Venn diagram. You can use probability values on the Venn diagram. All right. So I'm going to use a percentage that they give me. Everything up here they're giving me as percentages. So when I put a number on my Venn diagram, it's going to be in percent. So 80% of the students purchase chips. So everything in my chips must add up to 80. So I'm going to put 80 right here. So here so must add up to 80%. 80% of my students. Right? I'm putting the percentages on my Venn diagram. My Venn diagram is showing me percentages. All right, so this is 80%. So here and here must add up to 80%. And the total has to be 100. And I'm showing my percentages on the Venn diagram. All right. Then now it says 55% purchase chicken cake. So this must be 55. I'm showing my percentages. So here and here must add up to 55. All right. Then it says, of the students who purchase chicken, of these students, says of this 55% students, 11% do not purchase chips. Now this can be interpreted two ways. Of the 55, 11% do not purchase chips. The chips here now. So it could be saying that they put 11 inside this. 11 and put 44 in here. But I don't think that is the right interpretation. Why? Why am I saying it's not the right interpretation? Because it said, of the student who purchased chicken, which is 55%, 11% of that 55% do not purchase chips. That's how I'm going to interpret. 11% of the 55%. So I'm going to place inside here 11% of the 55%. When somebody wrote that out for me. 11% of the 55%. I'm putting it 55% under there. Write that out for me. That must go inside here. These are the ones who don't purchase. Don't purchase.
6.05%.
How much?
6.05.
6.05. They said they don't purchase, or they don't purchase chips. Oh, don't purchase chips means that them inside here. So don't purchase chips means that they're inside here. Not purchase chips. They do not purchase chips. So this 11% of 55 ends up in here. So I'm going to put the 6.05, I said?
Yeah.
6.05. 6.05. So I'm going to put 6.05 right here. 6.05. Remember, everything in here is almost up to 55. You know? So it means that in the intersection here is 55 minus 6.05. Write that out for me inside here. So 65 minus 6.05. Write it out for me. I'm going to write it side here. So if everything in here must be 55, I may have 6.05 in here because it's 11% of the 55. That's how I'm interpreting this one. Some person would have put the 11 here and put the 44 here to get the 55. I think I'm doing it the right way because I'm reading the thing that says of the students who purchase chips, which is 55% of the students. Of this 55%, 11% of them, which is 6.05. Right? So I'm interpreting it that way. So tell me now, 55 minus 6.05 is going in here to complete this set of 55. What is it?
48.95.
How much?
48.95.
48.95 going inside here. And then everything in here must be 80. So inside here is going to be 80 minus this. Write that one for me. 80 minus this is coming inside here. Those are the ones who purchase chicken. Come again?
31.05.
And everything must add up to 100% because I am working in percentages. So this over here is 80%. This is 80%, and this is 6.05. So that already accounts for 86.05. So out here is going to be 100 minus 86.05. Out here, so that don't purchase chicken or chips. Work it out for me to complete the 100% of the students. Work it out for me. Work it out for me. Or if you want, you could say 100 minus this, minus this, minus. But you don't have to do that because you already know that all of this is 80. That is 80 plus the 6.08 is 86.08. And so the remainder must fit inside here. 100 minus
13.95.
how much?
13.95.
13.95. So all these numbers must add up to 100 because I'm showing the percentage of my students on this Venn diagram. But I go to that. That's my Venn diagram. Now that I have those, I can answer anything. I can answer any question now. It says, determine the probability, and these are percentages, and percentages are also probability, right? Percentages. So any value, any percentage I want. So this means that 13% don't purchase chicken or chips, you know. And 30% is still a probability. It's 30% out of the 100. It's 13 out of the 100, right? Out of the 100%. All right, ready now. So determine the probability. Determine the probability that a student chosen at random purchase only chicken or only chips, or means and. So only chicken or only chips are these, you know. These are the chicken only, these are the chips only. Right? Chicken or chips only. So if I look at the Venn diagram, I'm talking about only chicken or chips. So chicken alone is 6.05 and it's percent, right? Or 31.05. 31.05. I remember this is percent. What is work out to? Chicken or chips. So it's these or these. Those only or those only. Out of the out of
37.1%.
Come again?
37.1.
37.1%. That is it. If you want to put it as a thing there, it will be 0.371. If you want to put it as a value. 0.371 is the probability of getting a student that purchase chicken only or chips only. These or these. So you add them up. Next one. You done? That's it? Wow. Done. Let me ask something else. Let me ask something else. All right, that's it. Easy question. That's 1 mark. 5 marks for that. 4 marks for the diagram. 1 mark for that. All right, that's it. That's it. Easy question. Next one. The probability of the occurrence of two events A and B are given as this. As probability of A, probability of B, probability of the union. Remember, them two here must add up to be equal to them two here. They must equal. Right? That's what the probability theory says. Or this one equal the sum of these two minus that. This one I want, this one that I want. So this one equals probability of A plus probability of B minus the probability of the union. A union B. So it becomes a quarter plus 3/5 minus 7/10. Can somebody work that out for me, please? Understand what it is? Can somebody work that out, please?
Minus 11/20.
Can't be minus. Probability can't be minus. Huh?
3/20.
Oh. Can't be minus 3/20. You sure? Sure? All right. So why it said minus first? This one, the probability of A given that B has occurred. This one equal the probability of the intersection, remember, over the probability of B. Remember, how much of the intersection? What is represent again? You have the two sets like that. This means, and this is A and this is B. It means how much of the A here is inside of the B. That's what this probability means. How much of the A is inside of the B. All right, that's what it means. And how much of A inside of B is the intersection inside of the B. So the intersection, we'll just work it out. It is 3/20, and the B is 3/5. So this becomes equal to 3/20 over 3/5. What are we equal to? That equal 5/20, don't it? Or a quarter, don't it?
Yes, sir.
Yes, sir.
Now, as I see that quarter, watch this now. See that quarter here? As I look at it, it equal but the probability of A. See that? So it means that the conditional probability is equal to the probability of A. So it means that A and B are independent events. Simple as that. It just state with reason why A and B are independent. Simple. The conditional probability of A, given that B has occurred, is equal to the probability of A, which is a quarter. So the conditional probability are this is the theory for independent events. So the theory for independent events has occurred, and therefore A and B are independent. Simple as that. So it's one more for it. So you can say since probability of A given that B has occurred is equal to the probability of A is a quarter. A and B are independent. Independent events. Remember, the other way to do it, which what I messed up in the first question, is to check this probability of A intersect B. It's supposed to be equal to the probability of A times the probability of B. That's another way you could show it. What is this equal to? We worked out a while ago. It's equal to 3/20. It's equal to 3/20. Now this one is 3/20. What is this equal to? Probability of A is a quarter. Probability of B is 3/5. This equals 3/20 as well. So it also proves that they are independent because the intersection is equal to the probability of A and the probability of B. The probability of A and B is equal to the probability of A and the probability of B. Once you have that, they are independent. So we could have shown this as well. That's another way to show it. So we did it this way because it was obvious to us, but we could have done this as well. And that is it. Question done. So let's look back. Let's look at 20. Let's look at the specimen paper now. I'm going to take a break after this. I'm going to go back to the 2017 and just finish stuff. There's something that I skipped out. Just my brain just went there for a moment. All right. So this is the only question that said like this on the specimen paper. Notes I don't see any like this on the 2021 or the 2022. So I think you can look for a question similar to this on this year paper. With sample space and this kind of diagram and thing, all right? So you can maybe look out for something like that. All right. The 2022 finished a while ago. You finished it? Finished it, right? All right. Let's go. This question says, a tetrahedral die has 4 faces. 4 faces, and they are numbered 1 to 4. It's a 2 tetrahedral dice, 1 red and 1 blue, have faces numbered 0 to 4. 0 to 4 are numbered. It says the dice are rolled, 2 of them are rolled, and the number face down on the 2 dice are recorded. Red are the scores on the red, R are the scores of the red die, and the B are the scores on the blue die. Compute the probability of getting a red 3 and a blue 0. That's an unknown. So it's a multiplication thing. So this equal the probability of getting a 3 on the red die is 1/4 times probability of getting a 0 and the blue die is also 1/4. So this is equal to 1/16. 1/16. Simple as that. And they multiply, they are independent events. All right? Simple as that. Because if you do the sample space, guys, because it's a 4, because it's a 0, 1, 2, 3, and a 0, 1, 2, 3. You're gonna get 16 possibilities in here. 16 possibilities. And there's only one out of them you can get the red. Okay, so might be the red and only some might be the blue. You can get the red 3 and the blue 0. The red 3 and the blue 0. If you get 0, 3 down here, different. This should be a red 0 and a blue 3. We're talking about a red 3 and a blue 0. Only one time you can get that. 1 out of the 16. So calculation makes sense. So sometimes if you're not sure about the probability, think of the sample space. Think of a sample space. All right, let's continue. It says the random variable t is r multiplied by b. So multiplying the values. So these are the blue values. These are the red values. Here are the products. The multiplying them. So some question might tell you the sum of them. Some question might tell you the difference of them. Sometimes some question might tell you the quotient of them means you divide them. This one is giving us the multiple. So they want us to complete the sample space. Complete the sample space and show all the possibilities. You basically multiply the values, right? Simple as that, multiply the values. So all of these up here are going to be zeros because 0 times everything is 0. So all these are going to be 0, 0, 0, 0. Again, all of these across are going to be 0 because 0 times all these values will be 0. Print it out as easily as possible, 0, 0, 0. Then it's going to be 1 times 1 is 1 right here. Oh, wow. Sorry about that. Right? Right. So 1 times 1 is 1 right here. Right here says 1. 1 times 2 is 2. That is already there. Then we have 1 times 3 is 3. Then 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6 up here. So. Then 3 times 1 is 3. 3 times 2 is 6. And 3 times 3 is 9. So I have all the values right there. All right? All the values. Question says no. The table below gives the probability of each of the possible value of t. These are the value of t. There's values 0 to 9. Those are the values in the sample space 0 to 9. And they want us to complete the value for A, the B, and the C. All right, let's do A first. A is how many zeros are in the sample space. That's what it is now. How many zeros out of the 16? So A equals, that's the probability of getting a 0. There's how many zeros are there out of the 16? How many zeros are there in the 16? How many zeros are there in the 16? Let's count the zeros. It is 4 down here and 3 across. It makes 7. 7 zeros out of 16. That's 7 out of 16. So A is 7 out of 16 right here. They want the B. The B, put right here. So the B is how many 3s are there out of the 16? How many 3s are there out of the 16? How many 3s are there out of the 16? How many 3s? 1, 2, only 2 3s. So it's 2 out of 16. That becomes 2 out of 16, which is also 1 out of 8. And then C, this C right here, is how many 4s out of the 16? How many 4s out of 16? How many 4s? Only 1 4 exists there. Only 1 4. So that is 4 out of 16, which is a quarter. That is the answer. Question done. Simple as that. But good, let's go back to the 2017 that we did not complete. I did not show the other method to do it. 2017. Let's complete this. 17. The conditional probability. That's stop. 2017, that's 2016. 2017. That's 2016. 2016. 2016, first one. Right here, right. Right. So this one I was still trying to use this. I was still trying to use this. This is used only with that for independent. Other way to show independent events. We could say or we have to show the probability of A intersect B equals the probability of A times the probability of B. Right? Now the intersection, if we have it up here, see it here, it is 0.4. So this is 0.4 equal the probability of A, probability of A 0.5, probability of B 0.8. So 0.5 times 0.8. And this also is 0.4. So this is true. Because that is true, it means that the events are independent. But this is true. I've shown this to be true. The two ways you can show independent events, by doing this or by doing this. All right. Yeah, that is it. My brain just fried a bit when I was on it. So it caught back itself. All right, guys. So it's now 4:30. I think I what? Around 6. When I take a break, we're still not doing this. We're still not doing inequalities yet, you know. I'm gonna take a 10 minutes break and then we'll come back and do some inequalities. We didn't do any inequalities yet. All right. I'm gonna take a break and come back to some inequalities, which is very easy, especially the rational inequalities. All right. The rational inequalities and the quadratic inequality. But the rational inequalities is another form of thing. So not on every paper. But let's take a break. Let's take a break. I'm gonna search for the question. I'm taking a 10 minutes break, guys. 10 minutes break. So start back at 4:40. 4:40 on this, and 3:40 in Jamaica. All right. Time is it? Okay. 4:30. Right. 10 minutes break, guys. Let me start the clock. 10 minutes break. Ready, guys? Ready again? Ready, guys?
Yes, sir.
Yes,
All
sir.
right. All right. So I want us to do some inequalities. Very easy. It should take 10 minutes or less. We also want to do a question, linear reduction. We need to do at least one of that question, the linear reduction. All right, this one linear reduction. Just give me 1 second. I'm starting back. Just give me one moment. Don't move. Give me a moment. Okay, guys, sorry about that. All right. So let us talk about, in particular, rational inequalities. Types of this type, one like this. And of course, the syllabus says you are supposed to know how to do them. Less than or equal to 0, greater than 0, also less than 0, and greater than or equal to 0. That's what the syllabus says. All right. Now, these are quite simple. What it is, how it can be viewed is that what we are saying is that we have, for example, a fraction that is less than 0 means a fraction is negative. Now, if a fraction is negative, right? If we divide two values and it's negative, then if we multiply the same two values, it's still going to be negative. So it means that 3 minus x times 2x plus 1 will still be negative. Let's look at it another way. Positive over positive is positive. If positive over positive is positive, then positive times positive will still be positive. Positive over negative is negative. So if you multiply them and do instead positive, if you do positive times negative, it's still negative. That's one way to look at it as well. But The theoretical way to do it is to say we multiply both sides by the square of the denominator. Why do we multiply by the square of the denominator? So if I have this expression, 3 minus x over 2x plus 1 less than 0, I'm saying this to me implies automatically that 2x plus 1 times 3 minus x still will be less than 0. If the quotient of these two things is negative, then the product of the same two things will also be negative. That's one way to look at it. But how do we go from this to this theoretically? Somebody can tell me? Somebody can tell me quickly?
So multiply by the denominator squared on both sides.
You multiply by the square of the denominator. Why do we multiply by the square of the denominator and not just multiply by the denominator? Why is it that we multiply by the square of the denominator? Why? Why do we multiply by the square of the denominator?
So that one of the squares will get rid of the denominator, and then you'll get the two brackets, and then you'll expand it to get them quadratic.
No, that's not what I'm looking for. You multiply by the denominator squared. You multiply both sides by the square of the denominator because you want to ensure that you're multiplying with a positive value. Because when you multiply an inequality with a negative value, the inequality sign has to be reversed. So because we don't know what the value of x is, whether it's positive or negative, we are ensuring that we don't have to change inequality sign. So we multiply both sides by the square of the denominator. That is why we multiply by the square of the denominator. So regardless of whether or not you're given a rational function like that, or something even as simple as 2x minus 3x, say for example, over x less than 0, you still have to multiply both sides by the square of the denominator. Let's say, for example, this instead was a 1. You cannot just multiply x over here. You have to multiply both sides by the square of the denominator to ensure that you multiply by a positive value. So we multiply this side by x squared and multiply this side by x squared. And that's one. This one will cancel this. And this will become x times 2 minus 2x still less than x squared over here. Right? That's what you will end up with in this case, for example. So the point is you have to multiply by the square of the denominator because you want to ensure that you're multiplying with a positive value. So multiply this both sides by 2x plus 1 squared, and over here by 2x plus 1 squared. Then this cancels one of this, and we end up getting the product. We end up getting the product 2x plus 1 times 3 minus x less than, and this 0 times anything is still 0. That's what you would get. And then it becomes a quadratic. Now, if we're solving this using a sketch method, what do we sketch? Do we sketch a frown or do we sketch a smile? I just want to gauge the extent of your knowledge with this, guys. That's why I'm asking a question. There's a lot of questions to do.
So a frown.
Do we multiply? Huh?
So a frown.
A frown. Because if we expand this out, we're going to multiply this x by this negative x. So we will get a negative x squared expression, which means that we would need a frown. And if this is our horizontal axis right here, then we need those two critical values. We get the two critical values, which will basically be like the roots from these two factors. So this factor would give me a what? A 3. Because it is as if I put this equals 0. And so the x will be equal to 3. So one value here will be 3. And this one will give me negative half, because again, it's like I put this equals 0. And the x will be equal to negative half. So here would be negative half. And I'm leaving these circles unshaded deliberately because I don't have any equal in here. So I'm not including the values. All right? And then this inequality now, less than zero, would be telling me that I want this part of the graph down here below the x-axis, and this part of the graph down here that's below the x-axis. This part of the graph is obtained by values of x to the right of this 3, which means x has to be greater than 3. And this part of the graph down here will be obtained by values to the left of this -1, which tells me that the x has to be less than -1. -1/2, sorry, -1/2. So this got to be my solution. The question says that to put it in solution set, you have to write x is such that x is less than -1/2 union x is greater than 3 in set brackets. And that will be the solution. Everybody comfortable with that?
Yes, sir.
All right. Let's look at another scenario. We're gonna finish with this fairly quickly because you know it's not complicated. It's really very simple. All right. Let's say, for example, we can do this by example. Let's say, for example, instead we have so we have 2x plus 1 over 3x plus 2, and this now is less than or equal to 0. So I can look at that and know the answer. But how would you approach this? Now this is less than or equal to 0, so the possibility exists that you're going to bring the equal into play. You have to be careful now, because you have to remember that for this rational expression to be real, the denominator cannot be 0, cannot be equal to 0. So because the equal is 0, the possibility exists that you might give an answer that includes an equal that is not valid. And so you have to start by recognizing that the denominator, the 3x plus 2, cannot be 0, which means that the x cannot be -2/3. So when you come to this root to put your range on this root, you have to ensure that you do not include the equal. You do not include the equal. So and then we proceed in a normal way. We have to ensure that on the -2, we do not include the equal. So to progress in the normal way, we would multiply this by 3x plus 2 squared as normal, and it will become a product instead. 3x plus 2 times 2x plus 1 plus 1. The sign remains a less than because we multiply by a positive value, because this has to be positive, less than or equal to 0. And then because this x squared, that those two x values will multiply to give me a positive squared value. I know again that I have a smile-shaped quadratic. I have to be careful with these roots now, because both of them are negative. Right? This one is producing a -1/2, this one, and this one is producing a -2/3. This is my x-axis right here. So question is, which one of this or this do I put here, or which one do I put there? You have to know, compare them. One way to compare them is to make them have the same denominator. Remember, the negative x value increase in size this way to the left. So the smaller negative x value is going to go here, the larger one go there. All right? You have to be careful when both of them are negative. Careful when both of them are negative. So this one, if I write with a denominator of 6, it is the same as -3/6. This one is the same as -4/6. So this one is going to be further down here. But understand that. But I go to that?
Yes, sir.
Yes, sir.
Otherwise, you can write them as decimals. So this one will be -0.5. This one will be -0.7 or 0.66. Again, this one will be further down here. All right, so you can put them in decimal again if you want to compare them. Put them at the right place. Don't give it away. All right, so I'm gonna put the negative 3/6 right here, which is negative half. And this one then will be negative 2/3. This is negative 0.5. And this is negative 0.67. So clearly that is correct. All right. Sometimes when we have whole number values, I'm going to do another example just now with whole number values. I'm showing you the mistakes that are possible, right? Then now I'm going to shade, I'm going to mark these 2 points. But remember, this one cannot be equal. So I'm going to put the unshaded circle on this one. Remind me that I don't put the equal on this one. And I'm going to put the shaded circle on this one. Because that is fine. It's okay for the x to be z. It's okay for the x to be equal to negative half. Because it's on the numerator. This inequality, less than 0, means that I'm referring to the part of the graph under here. Below the axis. So it means that I want my values to be between these 2 places, this way and this way, between them. How do I write that interval? That's an interval, one continuous interval of values. So I don't write 2 separate inequalities. My x in between here is less than or equal to this value of negative half, but greater than alone. Don't put an equal on that side. Greater than alone. It cannot be equal to negative 2/3. Negative 2/3. That's my solution. If they want it in sets, I just put x is such that. They want it in set notation. X is such that. And I put the set brackets around it. But that is it. But understand that?
Yes, sir.
I need to do any more examples with this? Everybody okay?
Okay, sir.
Everybody okay? I don't need any more examples. You sure?
Yes, sir.
Yes, sir.
All right. So let me still give you one more example, since I don't need any more. So let's say I give you 4 minus x over x greater than or equal to 0. What do we do in this case? 4 minus x greater than or equal to 0. Same thing again. All right, let me not put 0. Suppose I give you this 1. What do you do? If I give you 1 right there, what do you do?
Multiply both sides by x.
No. Multiply both sides by x squared. You have to multiply by the square of the denominator. You have to ensure that you're multiplying with a positive value. You don't know if x is positive or negative. So you have to ensure that you're multiplying by a positive value by multiplying by x squared. So I have to multiply both sides by x squared. Multiply by here by x squared. Multiply by here by x squared. Multiply both sides by x squared. X squared is a positive value, and therefore it leaves my sign as greater than. My sign, I know it stays greater than because I'm multiplying by a positive value, not x. X squared, square of the denominator. And then I can simplify. So this side would become x into 4 minus x greater than or equal to x squared. But I go to that. Then it becomes a quadratic in x. And we could proceed. I'm just setting up something for you to see. All right, this will become 4x minus x squared greater than or equal to x squared. If I transpose everything over here, why am I transposing over here? Because I want my squared term to be positive. Then it will be 0 greater than or equal to 2x squared minus 4x. I can divide 2 by the 2 and get 0 greater than or equal to x squared minus 2x. Then I have to factorize the x. X into x minus 2. This is the same as x into x minus 2 less than or equal to 0. It's the same concept. Remember now, from here, at the beginning of what they gave me, if I erase what I put in there, I was supposed to start by saying the x, well, not this time, because I have a 1 over there. So there's really no restriction there, right? Because that's a 1. It's only when it's a 0, the denominator cannot be 0. So this time it's okay. So let me put this back. Multiply both sides by x squared. So there's no restriction because that's a 1. So a 0, the denominator cannot be 0. Right? So this will be a smile now. This will be a smile. One value will be 2 from this factor, x equals 2, right here. And I can shade it. And the other value would be 0 right here. Less than 0 would mean that I want between here, below the axis. So all my x values between here and there. So the x would be less than or equal to 2, greater than or equal to 0. All right? So remember, you have to multiply both sides by the square of the denominator, the square of the denominator. And you look if you have a smile or a frown. Remember, if the equal is there, you cannot put the denominator equals 0. The denominator cannot be equal to 0 if the equal is a part of the inequality in the original function. All right? So let's go. So we finished this one already. This is on the specimen paper, this one. I think there's another one. It's not, you won't see this question very often, right? Look, I think there's another one on 2021. Let's look at it, 2021. So we'll just finish this one here. They don't set it very often. Let's look at 2021. I think there's one on there. 2021. Let's see. See it here. There's one on 2021. So let's do it. That is it. It's only a less than, right? So you can proceed. Multiply both sides by 4x minus 9 squared, square of the denominator. So this side becomes the product of 4x minus 9 times 2 minus x less than 0. There's no restriction because there's no equal in this, so there's no restriction. All right? Because this and this minus x is going to create a negative x squared. If I expand it, I know that I'm working on a frown. This is going to give me 2. This is going to give me 9 over 4. 9 over 4 is 2, is 2 1/4. Right? Because this factor is going to give me x equals 9 over 4 as a root. And this factor is going to give me x equals 2 as a root. I'm trying to find where those values are on the x-axis. Right? So the 9 over 4 is clearly greater than the 2. Both of them positive, right? So I'm going to put the 9 over 4 here and put the 2 here. In fact, let me leave those circles unshaded. I'm going to leave this unshaded and leave this unshaded. Put the 9 over 4 here, that's 2 1/4, and put the 2 here. This less than 0 means that I'm talking about this part of the graph on here, down here. Less than 0, below the axis. This part of the graph is obtained by x values to the right of the 9 over 2 and to the left of the 2. So my x values have to be less than 2, or my x values have to be greater than 9 over 4. So my solution would be that x is less than 2 or x is greater than 9 over 4. If they want solution set, change this or to a union. I put x is such that, and I put them in set brackets if they want it in solution set. And that will be it. Don't get this question wrong from me, please. 4 marks for easy work. 4 marks for easy work. I think there's another one on 2017. No, 2019. Let's see. There's another one on 2019. Yeah, 2019 or 2017. Let's do 2019 or 2017. So Don't get these questions wrong. They're too easy. Don't get easy questions wrong. Let's see. Oh, there's none on 2019. Nope. There's none on 20. Why did I write 29? Why did I write 29? All right, that's it. There's none on 29. I think there's one on 2017. I don't need to do 100 of these questions to get it. See there, there's one on 27. And remember, when the equal is there, we have to be careful. It means that you have to remember that the denominator cannot be 0 because the equal is there, the possibility exists that we might write one solution as x equals -1, which it cannot be. The denominator cannot be 0. So I want you to write down when the equal is there, before you even start doing anything, that the denominator, the x plus 1, cannot be 0. And so the x cannot be -1. So when you put a -1 on the graph, you're going to leave it unshaded. Unshaded when you mark it on the graph. When these two are positive, so I know that I'm going to get a smile. But to show the process, again, I'm going to multiply both sides by x plus 1 squared. And that will cause me to have now the product. Because there's only 0 over there. So I'm going to have the product. So the quotient becomes a product. X plus 1 times 2x plus 3. This is greater than or equal to 0. Since this x times this x is going to give me a positive x squared, I know that I'm dealing with a smile function. This inequality relates to a smile function. This is my x-axis. I'll be careful because I'm going to get a negative value and a negative value. This one is going to give me -1. This one is going to give me -3/2. -3/2 must be furthered on this side because that's -1.5. Let's look at it. This factor is giving me -3/2. This factor is giving me -1 as my root values or my critical values. You have to place it in the right place. This is -1.5. Now this one is -1.5. Person might be tempted to put the -1.5 here and put the -1 over here, which is wrong. Good. When the values are negative, the magnitude of the negative value is greater more to the left. Don't put them in the wrong place when both of them negative. Is a common mistake. So for example, if somebody get like -2 and -3, plenty person make the mistake and put the -3 here and the -2 here, which is wrong. -3 has to be over here if here is -2. All right. So when you have two negative values, you have to be careful. Okay. So I'm working with -3/2 from this factor. I'm going to put it over here. And -1 from this factor here. I will remember this. I'm going to leave the circle right here unshaded because it cannot be 0. It cannot be 0. X cannot be 0 because this is what we are given. I'm going to shade this one. It's okay for x to be equal to -3/2. And then now I'm going to mark the region that my inequality is referring to. And use a perp for that. It's greater than 0. It's referring to the part of the graph above the axis. Right? It's greater than 0 is referring to this part of the graph up here and this part of the graph up here. Those parts of the graph are obtained by values to the right of the -1, and that's how we're going to get a value up here, and to the left of this value. That's how we're going to get a y value up there. The x has to be to the right of this and to the left of that. Over here means that my x has to be greater alone because I'm unshaded. Remember, it can't be equal enough. So greater alone than -1. But x down here can be less than or equal to this one, -3/2. So my solution is that my x is outside these two values. So my solution is that x is less than or equal to negative 2 over 2 on this side, or my x is greater than negative 1 alone on that side. So that will represent my solution. See? Determine the rate. So I could leave this as my answer for this. But if the question says solution set, then you have to change this or to a union, put the x is such that, and put them in your set notation brackets. If the question says solution set. Everybody go to that?
Yes, sir.
But okay, good. All right, and just for emphasis, if we had the same inequality, basically, over here, 2x plus 3 over x plus 1, but if instead it was less than or equal to, everything would be the same down to here. We'd still get the x plus 1, 2x plus 3, but we would have less than or equal to 0. Again, we'd have to say the x cannot be negative 1, just as we did here. So we have this. It would still be a smile because the x times x in the expansion would give me a smile. This factor would give me negative 3 over 2. This factor would give me negative 1. 3 over 2 is negative 1.5. So it means again that I will working with this point, but I put it on shade because it cannot be 0. So that will be negative 1 and shade this one for negative 3 over 2. And the less than 0 now would mean that I want this part of the graph under here, part of the graph below the x-axis. That part of the graph are obtained by x values here, inside here, x values inside there. So I would want x values that are less than the negative 1, but greater than the negative 3 over 2. That is one continuous interval of values that I would want, because I want this continuous section of the graph. It's not two separate sections like here. It's one continuous interval. And so my x value in between here would have to be less than the negative 1. But at the same time, an x value inside here would be greater than or equal to, because this is shaded, the negative 3 over 2. And this would be my answer, my range. But I go to that. But okay?
Yes, sir. Yes, sir.
Yes, sir.
All right. This question carry a lot of marks for very easy work, guys. 4 marks. So make sure you get it right. Okay? If you put an equal on this end, you're not going to get the marks. If you put an equal, like in this one over here, if you put an equal on this end, you're not going to get the marks. Because it cannot be 0. The denominator cannot be 0. The denominator cannot be 0. So you cannot put the equal on the one that will make the denominator 0. All right, enough of that. The next question I want to do is a question on this same paper. And it's the only one I'm going to do. It's a linear reduction. All of them is the same. If you can do one of them, you can do all of them. All right? It's a linear reduction question where you have to draw a graph. I'm going to do this one example. And then what we're going to do after that, we're going to do a multiple choice paper. Now, let me tell you why I'm doing a multiple choice paper. I know you have a paper 2 tomorrow. But the multiple choice paper, it helps the paper 2. Doing multiple choice helps paper 2. And also, what will happen is that we'll cover a wide range of topics during the multiple choice. So I want us to finish off by doing a multiple choice. I think I would have covered all the topics in these 4 sessions over the last 4 days. All right? Over the last 4 sessions. I think we actually did 5 sessions in 4 days. But there was one day we did 2 sessions. All right, so let's go. So this question is a linear reduction question. Reducing a relationship to a linear form. And you have to draw the graph and get the best fit graph and all of that. All right? So they give us this relationship. Question says the variables P and Q. Let me make this large. It's the only one I'm going to do like this. Variables P and X, sorry, in table 1 obtained from an experiment are thought to obey this law of this form. That's the relationship between them. All right, and then they give us these values in a table. All right? So clearly, the X and the P are your variables. And so the A and the K are constants. All right? So these are your variables. See? They are changing values, the X and the P. And the A and the K are constants. It says use logs to reduce it to a linear form. The linear form is y equals mx plus c. We're trying to get it in that format. The m and the c would basically form from the A and the K, your constants. The X and the Y would form from your variables. This X and this P. You're gonna take logs and you're trying to get it in this form. Everybody should know to do this. Taking logs of both sides of this, right? So start out this way. Not a lot of space to work with. So start by saying the P, let's start up here. The P equals AX to the minus K. You take logs of both sides. So you take the log of this side. I'm just going to write LG for logs, log to base 10. And take log of this side, log to base 10. I'm going to use the laws of log and split this out into a sum of two logs, because that's a product right now. All right? So this expression, I'm going to write what it becomes down here, just because I don't have the space. So it's going to become the log of P equals the log of A plus the log of X to the minus K. Remember, we're trying to get it in this format. You know? This is already a constant. That's my C. Log of X is my variable X. I use the laws of log to bring this K to the front, minus K. All right? And to get it to resemble this, I'm going to put this expression in front of this one. What am I going to get? I'm going to get the log of P equals this one now. I'm going to put it first. I'm going to bring the minus K to the front. I'm going to get minus K times the log of X. That's what this one became. It became that. Plus, this now is the log of A comes back here. The log of A. All right, if I were to compare these two now, these two, it means that my gradient is M. My y-axis intercept C is a log of A. So the gradient M is negative K. The C value on the line is log of A. My axis, my x-axis is a log of X. So my x-axis is a log of X. I use big X to represent my x-axis. And my y-axis is a log of P. Is a log of P. So because this is now in the form of a straight line, to get a straight line graph, I have to put log of P values against log of X values to get a straight line on a graph. All right? To get a straight line on a graph, I have to put log of P value against log of X value. It is in this format. But understand that. What about that?
Yes, sir.
Question says, using a suitable scale, plot a best fit graph, use the plot a best fit line of the equation in C1 on a graph provided on page 9. Use the space provided for your calculations, for your workings. So the best fit line is going to be log P against log X. The minus K is going to be my gradient. Y-axis intercept is going to be equal to the log of A. I have to use these values. I have to use these values now to get the log of P and the log of X. So I'm going to use these values down here. Put them in the table. So I'm going to draw another table for the log of X and the log of P corresponding to these values. down here. All right, corresponding to those values. All right, so already know. So I need my calculator. Just work that you have to do, guys. Everybody have to do the same work in the exam room. A lot of calculation, but you just have to do it. All right, you just have to do it. Let me shift this over so. All right. So I'm doing the log of these values. I can do the log of these values first. Let me put the lines between them. Line them up under these. Line them up under these. Right? Line them up under these. Line up this one. Line up this one. And then have the last one out here. All right, I'm going to do the log of each of these values first, the top values, the x values across here. Put those first. So I'm doing the log of 1.58. I'm going to go for 2 decimal places. 0.1 decimal place, 0.20, 0.2, 2 decimal places, 0.20. Then I want the log of 2.51. 2.51. That's 0.40 to 2 decimal places, 0.40. So this value is coming up nicely. Then I want 3.98. 3.98. That's 0.60. So you see, these are in good interval. All these values are in good interval right now. They're making good interval, friendly interval. Then I want 6.30. 6.30. That is 0.80 to 2 decimal places, 0.80. Then I want, well, 10. The log of 10 is 1, so that is 1.0. So those are in good intervals, 2, 4, 6, 8, 0.2, 0.4, 0.6, 0.8. So on the x-axis, I'm going to use intervals of 0.2, 0.4, 0.6, 0.8. Then I'm going to do the log of these values now for here. Ready? So it's 121.5, 2.08, 2.08. Let's put that, 2.08. Next value I'm going to use 2.08. Next value I'm going to use is the 110.6, 110.6. That's 2.04. I'm working 2 decimal places, 3 significant figures. Then I want 106, 106.2, 106.2. That's 2.03, 2.03. Again, this and this, I'm going to be working in 0.01 intervals, 0.01 intervals. I can see that on my y-axis, it's going to be in 0.01 intervals. Then I want 99.1, the log of 99.1, that is 1 point, that's actually 2.00 to 2 decimal places, 2.00. So that becomes 2.00. Then I want this value now, 93.8. 93.8, that's 1.97. 1.97. So if you look at this graph, look at the value, they're extremely close. They're extremely close. So you have to use a scale, for example, on this axis. You have to choose a scale carefully now. Right? These are the decimal places that are changing. You notice that? So you have to go like 0.01 centimeters, 0.01 units to 2 centimeters. So you can go 2 centimeters to 0.01. Because those are the digits that are changing, the 100th place. Right? The 100th place is changed. You have to be smart with your scale. And on the y-axis, or on the x-axis, sorry, on this axis, I can use a scale. And this axis is the 1 decimal place value is changing. So I can use maybe 1 centimeter to 0.1 unit on that scale, on the x-axis scale. Something like that. Or maybe 2 centimeters to 0.01. 2 centimeters to 0.01 on the x-axis. So you have to look at the decimal place that is changing. It's the second decimal place that is changing. So your 2 centimeter has to go in that second decimal place interval. Be smart. Be smart. All right, let's go. I'm gonna put them on the graph now. The only problem is that let me bring this up on the next side of the page because I want to be able to see the graph. All right, so I'm gonna draw the graph and then we're gonna estimate these values next on the graph. All right. So let me bring these values up over here. So we can have them looking at when we're drawing the graph. So I'm gonna just bring these values up over here on this side of the screen. Just so that we can have them looking at up to and just paste them over here. Just because I want to have them looking at while I do the graph. All right, so let's go now. So we're doing the graph. So this is the graph. Right? And I'm gonna just work with my x-axis. You have to draw the arm. You have to be smart. No, look at the scale now. The scale for the y-axis, the scale for the x-axis is fine, you know. We can start from 0. For the x-axis, we can start from 0. Not even x-axis, it's a log x-axis. The log x-axis. This axis is a log x-axis. Log of x-axis. And the axis up here, the axis up here is the log of p-axis. Don't call it x and y. Log of p-axis. All right. So the horizontal axis is okay to start from 0. Right? It's okay to start from 0. I was saying 2 centimeters to 0.1. Right? So this will be 0. This will be 0.1, 0.2, 0.3. Going up to 0, going up to 1, would that work? 0.4, 0.5, 0.6, 0.7, 0.8. So that wouldn't work. So that can't work. It's not wide enough. So we're going to change it and put 1 centimeter to 0.1. What's that? Wait, remember it's recorded. No, man, it's recorded. So you can just watch the video. We're running out of time. So you just watch the video. The video is there. The video is there. So you just watch the video. Okay? So we're going to 1 centimeter to 0.1. Remember, I know a lot of persons here. So I could work in a way that benefits the majority. So watch it. That's why it's recorded and it's recorded. Remember, guys, anything you miss, you can watch the recording on YouTube. It's a live recording. You can just watch back the video on YouTube. If you miss something because you came late, watch it back on YouTube. All right? Watch it back on YouTube. All right. So I want to make this point. Did we say that? Let me see. Let's go back to this. All right. So we want to make sure that we can get out to 1, right? We can get out to 1. So let me see. So 0.1, 0.2, 0.3, no, 0.2, 0.4, 0.6, 0.8, and 1. You have any chance. 0.2, 0.4, 0.6, 0.8, 1.0. All right, because if we go 1, 2, 3, 4, 5, 6, 7, 8, we won't get the last value on the graph. All right, so we won't get the last value on the graph. So we are stuck with our choice. So we just use this small scale. Then on the vertical axis now, look at this now. We can't start at 0 on the vertical axis, you know, guys. We can't start at 0 because we're using a scale of 2 centimeter to 0.1, for example. 2 centimeter to 0.1. 0.01, I mean, 0.01. Right? So, because this starts at 1.97 and it goes up to 0.2. If we start at 0 down here, we won't finish the graph. So you have to start at a value way down here, like maybe 1.95. Since 1.97 is not a part of it, you can start at 1.96. Down on the x-axis here. So that's where you have to start. Right? Be smart. You have to start at a value like that. Down here on the x-axis. So down here, I'm starting down here at maybe 1.96. So I can put in my 1.97. I'm doing 2 centimeters to 0.01. So basically, then this would be 1.97. I'm changing the second decimal place every 2 centimeters. Then this would be 1.98. Then 1.99. Then this would be 2.00. Then this will be 2.01. We'll go up to 2.08. And so maybe that didn't good enough either. You have to use 2 centimeters to 0.2. Okay, graph when I finish, you know. See it? So you have to change it. 2 centimeters to 0.2 or 1 centimeter to 0.1. Don't have any choice. 1 centimeter to 0.1. We don't have enough space. So you see, 1 centimeter to 0.1. So still have to change it. Still have to change it. It happens. So therefore, this is gonna be 1.98. 1.98. 1.98. This will be 1.97. This will be 1.99. This will be 2.00. This will be 1.99. Then this will be 2.01. So this is 2.02. 2.02. I have enough space to write it. This will be 2.03. This will be 2.04. 2.04. This will be 2.05. This will be 2.06. 2.06 right here. This will be 2.07. This will be 2.08. 2.08. That's what the graph went up to 2.08. So that's my graph. That's my scale. That's my scale. All right. And then we're plotting the values now. Plotting the values. Let's plot them in. Let's keep them in red. So that's showing the graph. So the first point is 0.2, 2.08 up here. 0.2, 2.08. That's right here. Right up here. So this point. Right here. This point. Next point is 0.4, 2.04. 0.4, 2.04. 0.4, 2.04 is right here. Next point, 0.6, 2.03. So that point is going to be out. 0.6, 2.03. That's right here. So that point is going to be out. You're going to draw the best fit line just to see it. Right there. Next point is 0.82. 0.82 right here. 0.82. 0.82. Next point is 1.97. 1.97. This is 1.97 right here. So it's 1.97 right here. Those are your points. Then you have to draw your best fit line through those points. I don't have a ruler, guys. I'm going to draw it with my free hand and work with what I get. But you draw your best fit line, a straight line, a best fit straight line. Let's use the blue ink. Best fit straight line. So the best fit line, you want it to pass through the majority of the points. And if you can have an equal number of points above and below, but CSEC will give you your marks, whatever you draw. So these lines look like the line, these points look like the line up, these points look like the lineup, and like this one is the one that is a little bit off. So I'm not going to use those like that. Extend it back to the y-axis. All right, let's say that this is it. Draw it with your ruler. Don't draw it with the freehand line. Use a ruler, draw the best fit line. All right, don't draw it with your freehand line. I don't have a ruler to draw it. That is your line. Right? And from this line, you need two things. You need a gradient. You need a gradient. Remember, the gradient is going to be equal to minus k. And the c value is going to be equal to the log of a. Where the graph intersect the y-axis is going to be equal to the log of a. Whatever value cross the y-axis at equal to the log of a. So let's do that now. So let's estimate where this point is. Where is this point? Follow the same scale. That value, that value, this will be 2.09. This will be 2.10. This will be 2.10 right here. I'm saying that this is the point where it crosses the y-axis. So you mean that the C value, which is equal to the log of A, is 2.0, 2.10. That's what we're saying, you know. The C value is 2.10. And that is the log of A. It is 2.10. So it means that the log of A is 2.10. That's where you're going to find the A value. So the log of A equals 2.10. Then the gradient, you're going to use 2 points for the gradient. I'm going to use 2 points for the gradient. Now, I can use 2 points on the graph itself and calculate the gradient between them. Rise or run, that's going to have a negative gradient actually. Or I can use, for example, the x-axis intercept and the same y-axis intercept. So this point where it crosses the x-axis, this is 0.8, this is 0.9, this is 1, then this right here would be 1.1, right here would be 1.1, 1.1, right here, 1.1. And here we said it's 2.08, up here is 2.08. So the gradient would be rise 2.08 over run 1.1. As I said, you could use 2 points on the graph and calculate the gradient as well. Difference in y over difference in x. But if I have that y-axis intercept 2.10 and this x-axis intercept 2.1, I can do the calculation over here and say my gradient is rise, which is a negative 2.10 over run out to here 1.1. And this gradient is equal to negative k. This gradient, remember, is negative k. See here? The m is negative k. So I can say negative k equals negative 2.10 over 1.1. The negatives cancel, and so the k becomes 2.10 over 1.1. Can somebody work that out for me, please? I'm going to work this here. Don't put it here. So I'm saying the k is equal to 2.10 over 1.1. And work that out. And then for the a now, we are saying that the log of a equals 2.10 from the graph up here. From the graph down here. The log of a, which is a c value, the log of a equals 2.1. And the log of a equals 2.1, then the a equals 10 to the power 2.1, inverse log of 10 to the power 2.10. But understand that because this LG is log to base 10. Log to base 10. So the a equals 10 raised to the power 2.1. And so you can work this out for me and work this out for me. Work them out for me, please. What is equal to for the key?
So 1.91.
1.91 is the key, and this one 10 to the 2.1. What you get for that?
125.9.
125.9. That's it, guys. I don't need to do another example. If you can understand and do this one, you can do all of them. They are all the same if you should get one like this. All right? All right. So person is asking for some stuff to be done over. Guys, the video is there. I don't need to redo anything that I did today. But the video is there. The video is on YouTube. All right? I'll share the link afterwards and you can get it. But the video is there on YouTube. You go on the channel, the Rafik K Short channel, you'll find the video there live going on now. If you want to stop now and rewind and watch the part that you're interested in, you can watch it. All the videos are there that we did for all the topics. All of them are there. So any part of it you want to watch over, it's there. All right, so we would have completed all the topics for at least the papers between 2016 and 2023. I also did some papers down to 2012. I'm suggesting now that we do a multiple choice paper in full, right? finish the session. That way we get a chance to touch all the topics. Right? What time are we finishing, Kai? An hour and 20 minutes? An hour and 20 minutes, yeah? Huh? It's 6 o'clock, so we're gonna finish. Really? So the time up. All right. All right. If you want, we can do a multiple choice. I think it's a good idea here, 6 now. If you want, we can do a multiple choice. We can select the questions that we do and run through it quickly. Just for another quick set of revision. Let me see. Or we can call it a night. And I wish you good luck. And all right. The multiple choice helps the paper 2. Paper 1 helps paper 2 all the time, right? So I have some multiple choice here. This is 2021. This is 2021. Let me see. It's a 2021 multiple choice paper. All right. See, that's a multiple choice paper 2021. You go through them, you can just run through them quickly. You can run through them quickly. Right. It's only 45 questions, not a lot. You can finish these rather quickly if you like. So I'm going to go through the papers. I'm going to go through this paper. Those of you who wish to leave, you can leave. Those of you who wish to stay, you can stay. All right, 2021 paper. Now we can look at the specimen paper. We can look at the specimen paper. Specimen paper is in this document over here. Show you. Specimen multiple choice paper. Here. It's up top. So that's a specimen paper. That's a specimen paper, which I think is a good paper to run through. That's a specimen paper. We can run through this paper quick and fast. Let's do this. If you want to go, you can go. I'm gonna do it. All right. Should we finish this quickly? It's okay. Yeah. All right. So guys, I'm gonna run through this multiple choice paper, and we try to do it quickly. Right? Just a chance to touch back on some of the topics, and we'll go as quickly as we can. All right. So if you want to leave, guys, you can do so. I'm gonna go through this paper quick and fast. Okay, let's see. This question says, given that this function, this is a factor, what is k? In other words, it means that f of 2 is equal to 0. That's how you're gonna find k. F of 2 equals 0. That is the bottom line. And so we're gonna plug 2 in this and equate it to 0. So 2 cubed is 8. Do it over here. 2 cubed is 8. Then that is also 8. And then this is minus 10 plus k equals 0. So this is 16 minus 10 is 6 plus k equals 0. So the k equals -6. Voila, k equals -6. Done. This one now. This is equal to, this is algebra. This is algebra. So what we can do, we can expand it out into separate terms first. So, and then factorize. All right, that's what they did. Let's see. That's what they did. They factorized, expanded it out and simplified it basically. So it's lm plus ln minus ml. I can say lm again. I can say lm again. And then minus mn. And then what you find is that this value and this value eliminate each other. We have ln minus mn left. Factorize the n, you get l minus m. So n into l minus m. N into l minus m, which is this one. It's a simple algebra, that one. These are functions. and they wanted to complete the square. Right? Basically, they want us to complete the square quick and fast. So I'm going to write it firstly as minus 2x squared minus 8x minus 5. I'm going to factorize these two and get minus 2 into, careful, this becomes a positive. So it's x squared plus 4x minus 5. Then there's minus 2 into x, and half of this is 2. Don't forget the square minus the square of that, which is 4. And then minus 5. And then expand it out to get minus 2 into x plus 2 squared. Minus minus give me a plus 8. 8 minus 5 is plus 3. So I'm looking for this one. All right. So it's 3 and a minus 2 and plus inside. See, plus inside. So that says this one. Be careful with the plus inside there. All right. This one now. It says the nature of the roots of the given quadratic equation is described as real and distinct. If it's real and distinct, then b squared minus 4ac is greater than 0. Voila, that's it. All right, real and distinct. This one, boom, bang. This, given that the maximum value of this and the value of x, given that range, given this range, the maximum value of this and the value of x, which is the maximum, that's this. All right, so they give us this thing. So the maximum value is 4, as it's a quadratic. The maximum value is 4. So it's one of these. And it's when this inside the bracket equals 0. It's when x plus 1 equals 0, get that maximum. So it's when x equals minus 1. And the maximum value is equal to the value 4, constant out here. So the answer is simply this one. Right? Simple as that. Just testing our knowledge of getting the maximum and the value of x, which is maximum as a quadratic. Easy stuff. Next one up here. This one says alpha and beta are roots of this equation. And what is this? So we want to consolidate these values. Nice and easy. Multiply this one by beta over beta. So you get alpha beta over alpha beta, plus multiply this one by alpha over alpha. So you get alpha beta, no, by beta over beta. Well, beta on the denominator. So you get multiply this one by beta. Let's go again. Mistake. Multiply this one by alpha over alpha. Multiply this one by beta over beta. I want them to have the same denominator. So it's alpha squared plus beta squared over alpha beta. Let's shift this over. And then this now on the numerator is alpha plus beta all squared minus 2 alpha beta, and dividing that by alpha beta. This is like a full question, you know, guys. And then the alpha plus beta is minus negative 4 over 3, so it becomes 4 over 3. And the alpha beta is c over a, so it becomes a third. So you plug in those values in here now, so it becomes the sum, which is 4 over 3 squared minus 2 times a third over a third. And you put that in the calculator and see what you get. You can use the calculator in the multiple choice. Remember, just put that in the calculator and see what you get. So we get 4 over 3 squared, which is 16 over 9. So we get 16 over 9. Now we're minusing 2/3. 2/3. And we can bracket this up in the calculator and then divide that by a third. I'll get 3 1/3 as a fraction. This is 10 over 3, so the answer is right here. So this question could well have been on a paper 2. This one is an inequality to solve, transposing standard form 2x squared minus 5x minus 3 less than 0. Factorizing this to find the two roots, 2x and x. You have to put the 2 with the 3 to make it 6 and 1 right there. Signs are different. The greater one, the minus. The minus and plus here, less than 0. So if you sketch it, one root is 3, and the other root is minus half. Minus half. And this less than means that you want under here. So your solution is between minus half and 3. Between minus half and 3. So this is the answer. Between minus half and 3. Number 8. This one is easy again. Look at it. You don't have to work it out, you know. Since this is the x and this is the x, you're going to get a smile when you multiply it out. You're going to get a smile. This root is giving me -1. This factor is giving me -1 right here. This factor is giving me 3/2 right here. Greater than means that I want up here above the axis. And so I am to the right of that and to the left of -1. Right? So it is this one. Less than -1 and greater than 3/2. Quick and fast, nice and easy. Again, this could be on a paper 2. That's why I like to do the multiple choice. As the paper 1 helps the paper 2. That could have well been on a paper, on a paper, on a paper 2. All right, let's continue. These are indices question. All right. In the exam, and you're not sure to do this, you can actually just put the values in the calculator and see which one of them satisfy that. But this now can break this down, everything down to base 2 to solve it, right? Break everything down to base 2. This is 2 to the 1. So this becomes 2 times 2. This is 2 squared. So multiply the squared by the 2x up there, the x plus 1. So it will become 2 to the 2x plus 2, 2 to the 2x plus 2 equals, this is now 16. 16 is 2 to the 4th power. So it becomes 2 to the 4 times that 2x is 4 to the 8x. Then you add this power now, right? So it becomes 2x plus 3, sum of that equals 8x. So it becomes 6x equals 3 if I transpose that 2x. And so x equals 3/6, which is a half. Answer is a half. This again could have been on a paper 2. Next one. I'll give you this to solve. When the thing that you want is in the power, you take logs. First, the both of them squared. So it means that the 3 to the x is equal to 14. Because both of them squared. So the 3 to x is equal to 14. Then to get the x out of the power, you take logs of both sides. So you log this side and you log this side. You take the x out of the power. So you get x log 3 equals the log of 14. Then divide by log of 14. The x equals log of 3, I mean, divide by log of 3. So x equals the log of 14 over the log of 3. That's it. Easy. This again could be on a paper 2. Next question. Calculate the value of this now. This now, if you don't know how to work it out, it is all numerical. You can plug it in the calculator. It's all numerical. You can put it in the calculator and see which one it is. But it is all numerical. Make sure you have a calculator that can work out all of that. But if you're using the laws of logs, this one means that I'm taking the quotient. Log to the base 4 of 8 divided by 2 is 4. Plus, the plus here means I'm going to multiply by this 1/16. 1/16. So it becomes the log of 1/4. Log to the base 4, 1/4. This is the same as 4 to the minus 1. So the log of the base 4 of 4 to the minus 1. The minus 1 goes to the front. So it becomes minus 1 log of 4 to base 4. This equals 1. So the answer is -1 times 1, which is -1. Simple as that. But again, it is all numerical. So you could type it in the calculator. Just put it in the calculator and the answer will give you the -1. All right, moving right along. Next question up here. So you're going quickly. This one is first rational. This again, you can type this in the calculator and it is a numerical question. It's all numeric. So you can put it in the calculator, but if you were to work it out, I'm going to put these so that they're in the same order. So I'm going to write this as √3 plus 1 instead, over √3 minus 1. Then I'm going to rationalize the denominator by multiplying by the conjugate. Multiply by the conjugate of this. So I'm going to multiply under here by the conjugate to turn it into the difference of 2 squared. Root 3 plus 1. Since I have a minus here, I'm going to put a plus here to create the difference of 2 squared. But if I also multiply up here by root 3 plus 1, then the numerator is a perfect square, and the denominator is the difference of 2 squares. So working it out. The numerator is a perfect square because the first term squared is 3, then twice the product of the 2, that's 2 root 3. Second term squared is 1 plus 1. The denominator is the difference of 2 squared from this squared, which is 3, minus this square, which is 1. So the numerator becomes 4 plus 2 root 3 over 2. Divide each of these by 2. I get 2 plus root 3. This becomes a 2. This becomes a root 3. 2 plus root 3, same as root 3 plus 1. That is it. But you could put this in the calculator, guys. And the calculator probably will simplify it down to that for you. Try it, okay? Put this in the calculator and see if you get this. Put this in the calculator exactly as that and see what you get. All right, some calculator can do that for you. This one now, they give us this to work out. Huh? Oh, see here, this. Put it in calculator. 1 plus root 3 over root 3 minus 1. Is equal. What again? You get this one? You get 2 plus root 3. Good. So the calculator will rationalize for you. All right. So when the questions are numeric, use a calculator. All right. This one now. This is the sum of this from 1 to 20. That's a AP now. You plug in 1 first. You're gonna get 3 times 1 is 3 minus 1 is 2. You plug in 2. When you plug in 2, you're gonna get 3, 2 is 6. 6 minus 1 is 5. And when you plug in 3, you're gonna get 3, 3 is 9. Minus 1 is 8. So that's an AP with a first term of 2 and a common difference of 3, and the number of terms is 20. N equals 20. So you plug it in the formula. I could find the last term as well by plugging the 20 in there if you want it. But the sum becomes n over 2, which is 20 over 2 into 2a. 2 times 2, 2 times 2 plus n minus 1 is 19 times d. The d is 3. If you plug it in the formula for AP. This out here is at 10. Write that out for me and tell me what you get.
B.
Write that out for me. Huh?
B.
B. B. Good. So you recognize that this is an AP, guys. Common difference is 3 and the first term is A. All right, let's continue. This one's a GP now. It says first term of a GP is 16. A equals 16. The fifth term is 81. The fifth term is AR to the fourth power is 81. Given that the common ratio is positive, what is the value of the fourth term? The fourth term is AR cubed, or it is the term before the AR cubed. So what I can do, I can divide this. A is 16 enough, so I can put the 16 right here. So it means that 16R to the fourth power equals 81. So R equals 81 over 16 to root 4. Write that out for me, root 4. Root 4. 81 over 16, root 4. Show 2? Show 2. And therefore I want what? I want the fourth term. The fourth term is AR cubed. That is 16 times 3 over 2 cubed. That's what I'm working out. This is 27 over 8. That's 2 times 27 is 54. That's it. Done. See, this question could be on a paper too. The first 4 terms of a convergent geometric series are these. If it's convergent, it means that the R is less than 1 or greater than minus 1. The R is a fraction because it's sum to infinity. You want to find the R? This is the A. This is the A. The A is 81. A equals 81. You want to find the R. The R equals a term divided by the preceding term. Use the 2 easiest values. The R equals 3 over 9, which is a third. The sum to infinity is A over 1 minus R. So it becomes 81 over 1 minus a third. 1 minus a, not 1 minus 3, 1 minus a third. You can simplify this quickly. By multiplying up here by 3, I multiply under here by 3. So I get 3 times 81 over 2. 3 times 81, 3 times 81. 3 times 81 over, this becomes 3 minus 1, which is 2. 3 times 81 over 2. Which one says that? One of these. 3 times 8. 3 times 81 over 2. Where you get it? Get that?
C.
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 All right. Simple as that. Hope everyone understand what's happening here, right? That this also could be a paper 2 question. All right, reach 1/3 of the way. Let's go. Next question says, according to the point A and B are these, respectively. The perpendicular bisector is. So you want the perpendicular bisector, so you mean that you need the midpoint. So like you have these 2 points, and they're asking you for this. And this point is 2 minus 3, and this point is -10, -15. So this again could be a paper 2 question. So you need the midpoint. 2 points you need the midpoint, which is the average of these 2 x values. 2 minus 8, 2 minus 10 is -8 over 2 is -4. You need the average of these 2 values. Average of those 2 values is -4 as well. Then you need a gradient between these 2 points. The gradient between these 2 points, the m, is the difference in y over difference in x. So it's going to be -5, or we can do this point minus this point. Difference in y over difference in x. -3 minus a -5 is -3 plus 5, which is 2. And then this 2 over -10. 2 over -10 is 2 plus 10, which is 12. That becomes 1 over 6. So the perpendicular gradient is -6. Negative reciprocal of that. Using this gradient and this point to get the equation. So it's y minus a negative, y minus the y value, it becomes a y plus 4 equal to -6 into x minus x value is a minus 4, becomes a positive 4. So it's y plus 4 equal -6x minus 24. So this 4 goes over here and give me -28. So it's y equals -6x minus 28, which basically is this one. No, not that one. If I transpose everything over here, I get this one right here, B. That's it. So this again could have been a paper 2. That one could have been a paper 2. That's why I tell you the paper 1 helps the paper 2. It's good practice. This one down here, it says this line and this line intersect at a point P. Calculate the coordinates of P. You can solve them simultaneously, but if you don't show, you can plug in the values in them and see which value works for both of them. All right, I want to solve these 2 equations simultaneously. Quickly, I'm going to multiply this one by 2. So I'm going to get 2, multiply this one by 3 and eliminate the x. Multiply this one by 3 and eliminate the x. I'm going to have multiply this one by 3. I'm going to get 3y plus 3x plus 3 equals 0. And then I'm adding it to this one. So 2y and 3y is 5y. The x values are eliminated. Then the -13 and the +3 give me -10 equals 0. So the y equals 2. So it's either this or this. So I'm going to plug the 2 now in this equation. Plug the y equals 2. Plug the y equals 2 right here. So I'm going to get 2 plus x plus 1 equals 0. So this and this is 3, but the x has to be -3. So this is the answer. Solve them simultaneously. Again, that could be on a paper 2. Next question. The equation of a circle is given as that. What is the radius? We can calculate the radius from this, guys. Right? There's a formula to be calculated the radius. But I don't have a shortcut. I have to work it out. I don't keep the formula in my head to calculate the radius. There's a way to calculate the radius from that when it's in general form. I don't have a shortcut. I have to complete the square of these and work it out. So I'm completing the square of these first. It's going to be x plus 6 squared minus the square of this, which is 36. And then this don't have any y value in it. So it's going to be, oh, this and this is y, right? So it's going to be plus y plus half of this is 2 squared minus the square of this, which is 4. and then I'm subtracting that 60 minus 60. And then I'm adding up this. That's minus 40, and that give me minus 100. Minus 100. And the minus 100 will go on the other side of the equation to become equal 100. And I move these. Equal 100. And the 100 is 10 squared. So the radius is 10. That's it. I have to work it out. All right. Next one. Give me this vector that says the length of this vector is root 13. What is the value of k? The length is the modulus. The length is the modulus. Let me write about this. I wanted this to be my answer here. Right, so the modulus of this is equal to that. The modulus is the square root of 2 squared plus k squared. 2 squared is 4 plus k squared. That equal the root of 13. So I say this under here equal 13. So k, so 4 plus k squared equals 13. Subtract the 4, I get k squared equals 9. And so the k equals plus or minus 3. Answer is A. Done. That again could be on a paper 2. This one up here says the value of the real number t for which these two vectors are parallel. If two vectors are parallel, one is a multiple of the next. All I need to do is multiply this one to make it equal that. So what would I multiply this one to make it equal that? I would have to multiply it by 2. Multiply this one by 2. So multiply it by 2, I'm going to get 2b equals 4i minus 6j. So it means minus 6 equals positive t. T equals negative 6. But I understand that. This again could be on a paper 2. But I understand that? Good. So
Yes, sir.
Good. So the t equals this, t equals this negative 6. Just like that. Next question. Portion vector of A and B are these. What is the angle between them? Scalar product. Scalar product. It's cos to the minus 1 of the scalar product A dot B over the modulus of A times the modulus of B. This again could be on a paper 2. I tell you multiple choice good for that. Good revision. This could be a paper 2 question. Angle between two vectors. Scalar product first is this times this. See that the cos to the minus 1 here? So it's working out the values. This times this is 14, and this time this is 12. That's on the numerator. All right, that works out to 26. It's the only one with 26, you know, guys. So this must be the answer, you know. Bang. This must be the answer, 26. Go check the modulus if you want. Modulus of this one is the square root under here. Is the square root of 2 squared and 3 squared. See the 13 there? And then this one is the square root of 7 squared and 4 squared. That's 49 and 16. That's 65. See, that confirms it. This is the modulus. This is A dot B equals 26, which is up here. 26 is up here. Done. Better go to that. Better go.
Yes, sir.
Right. This next one, the trigonometry expression. Which one of these it is? All right. So basically, we have to just work this out. Right? We basically want to make them into one fraction. That's what it is. All of these are one value. We want to make these into one fraction. Once I see that all right, let's work it. Let's work it. Let's not preface it anything. I'm gonna make it into one fraction over here. So I'm gonna multiply this one with this denominator, numerator and denominator. So it becomes 1 plus sine x squared over cos x times 1 plus sine x. Plus, multiply this one now with this denominator. So I'm going to get cos squared x over cos x times 1 plus sine x. Make this small. 1 plus sine x under here. 1 plus sine x. They have the same denominator now, so I'm adding numerator. I'm going to expand this out first. I'm going to get 1 plus 2 sine x plus sine squared x plus this cos squared x now on this side all over the this is common denominator, which is cos x into 1 plus sin x. What happens now? These two give me 1. Sin squared plus cos squared is 1. These two is 1. Sin squared plus cos squared is 1. So I'm having 1 plus 1 is 2. So it becomes equal to 2 plus 2 sin x over cos x into 1 plus sin x. If I factorize the 2 out of these, I'm going to get 2 into 1 plus sin x over cos x into 1 plus sin x. And then these cancel. I'm left with 2 over cos x. So then it says 2 over cos x right there. Maybe we could have been done easier than that, but that's good enough. All right, that is that, 2 over cos x. Let's continue. Let's continue. Reach halfway almost. This one now, give me these two to work out. Easy stuff. The expansion of cos is cos, sin. I worked it out over here for you. I want to know which one they. When you do pure math, this one will be much easier for you. But this becomes the difference of 2 cos, which is minus sin. But anyway, that's when you do pure math. Expansion of this is cos, sin. So it becomes cos A, cos B. Since it's a minus, I'm going to get a plus sin A, sin B. That's cos, sin. Cos, sin. Then I'm subtracting this now. Minus that. Again, it's cos, sin, but it's a plus now. So I get cos A, cos B. Because of a plus here, I'm going to get a minus here. Sin A, sin B. Ready now? This minus this, that gone. This minus a negative, they become plus. So it all becomes 2 sin A, cos A. Answer is A. Done. Gotta go to that. So you have, when you know the trig identity in the head, much easier. This question now. Sin theta is 15 over 17 and the angle is obtuse. What is cos? Draw the triangle. The triangle is in the second quadrant. So the triangle is in the second quadrant of the circle over here. So if I draw the triangle, it will look like this. And the sign is opposite over hypotenuse. So this is 15, this is 17. That's an 8, 15, 17 triangle, but the 8 is negative because you're obtuse. You're in the second quadrant. So the cos is negative 8 over 17, adjacent over hypotenuse, adjacent to negative 8. Answer is this. That one, 8, 15, 17 triangle. So this one is the answer. If you know the Pythagorean triple, 8, 15, 17. Everybody good at that? Everybody okay with that?
Yes, sir.
All right. Next one. The smallest positive angle for which this thing equals 0. This is the most known sheet. If you have a sum sin cos equals 0, all you have to do is divide through by cos. Let me write it out for you. Sin theta plus cos theta equals 0. Just divide through by the cos. Divide this by cos theta, and divide this by cos theta, and divide this by cos theta. This becomes tan theta. Tan theta. This becomes 1 plus 1 equals 0. So tan theta equals minus 1. So theta equals tan to the minus 1 of negative 1. You can put that in a calculator, you know. You know what this is? If you were to follow the whole process, it's like you have your quadrant diagram now. You have your quadrant diagram. You want where tan is negative. Tan is negative. Tan is positive here and here. So it is negative up here. So I want the smallest value. Smallest value. It's also negative here, but I want the smallest one. Smallest one is in there. The principal angle for 1. The principal angle for 1 is tan to the minus 1 of 1. That's 45 degrees or pi by 4. Pi by 4. You want this quadrant. This quadrant is pi minus pi by 4. Pi is the same as 4 over 4. So that becomes 3 pi by 4. But your calculator could give you 3 pi by 4 for that. Test it for me, Kai. 3 pi by 4. Test it for me. tan to the minus 1 of negative 1 and tell me what you get. In radians. See if you get negative 3 pi by, you might get negative pi by 4. You get 3 pi by 4? Huh? What you get? Tan to the minus 1 of negative 1. What you get? What's one over to get?
45.
You get negative 45, put it in radians. Huh? What? Put it. Let me see it quick. You get minus pi by 4. That's a minus. Yeah, man, minus pi by 4. So it's a minus pi by 4 no mean that you're in this quadrant. So you have to do pi minus. Right? You're in this quadrant over here. So right? Minus pi by 4. It means that you're in this quadrant over here. Tan is negative. All right, let's go. This question says they want us to solve this. All right. 0 and 2 pi. All right. So it's for this solution. The solution exists in which quadrant? Now, if you're solving this, guys, you will get sine squared theta equals a quarter, right? You have to square both sides. So you get sine theta equals plus or minus half. It's because it's plus or minus, you're in all 4 quadrants. Your solution is in all 4 quadrants. You're where sine is positive and where sine is negative. So you're in all 4 quadrants. You want to where sine is positive here and here. And you want to where sine is negative here and here. And the principal angle for this will be 30 degrees or pi by 6. That will be the principal acute angle. Pi by 6. 30 degrees or pi by 6. Pi by 6 is equivalent to 30 degrees. Number 26. Let's continue. Number 27. What is this equal to? All right. Can do this 2 ways. Can do this 2 ways now. Watch this now. Can do this 2 ways. So we have the 2's are multiplying constant, right? So we have 2 sine of x minus pi by 2. So this looks like a complementary angle, right? Watch this now. You see the sine of x minus pi by 2. If I switch around these and make them negative, I have to do 2 times and then negate the whole thing. So it becomes times minus the sine and switch around these 2. It becomes pi by 2 minus x. Now you must know this relationship as complementary angles. Right? Complementary angles. Remember the sine of 90 minus theta equals the cos of theta. The pi by 2 is 90, you know. So I can replace this with the cos of x. Cos of x. So it becomes 2 times minus the cos of x, which is minus 2 cos x, which is equal to this one. Nice and easy. All right? That's the easy way to do it. That's the easy way to do it. You have to recognize this, guys, that the sine of an angle is equal to minus sine of minus the angle. I'll put another way. The sine of minus an angle is equal to minus sine of that angle. But when it comes to cos, the cos of minus an angle is equal to cos of the same angle. Now why that is so? Because if you look at this one, let me show you why that is so. The sine of minus an angle means that you are rotating down into this quadrant. Minus rotation, the minus angle means that you're rotating in this direction. And so it's taking you into this quadrant. And in this quadrant, sine of an angle is negative in this quadrant, right? Sine is negative. That's why it becomes minus sine of theta. And so why is the cos one positive now? Because the cos minus an angle, again, it is rotating you this way down into this quadrant. Where this will be the theta angle right here. But in this quadrant, the cos of an angle is positive in this quadrant. And that's why the cos of a negative angle comes equal to cos of the angle. All right? That is that. So remember, cos of a negative angle is equal to cos of the angle. But sine of a negative angle is equal to minus sine of the angle. More things you know, the better. This one, the cos of a plus a is the same as the cos of 2a. So it's equal to this one. No. That's not correct. That's not correct. Don't do that. That's not correct. It's equal to this one. 1 minus 2 cos squared. You see this? This has three possibilities. Three possibilities it has, this thing. Cos 2a can be written in 3 different ways. Can be written as cos squared a minus sine squared a. But then if you substitute for the sine squared by using 1 minus cos squared, then it could become 2 cos squared a minus 1. But if you substitute for the cos squared with 1 minus sine squared, then it will become 1 minus that I put a, I mean a. It will become 1 minus 2 sine squared a. So the cos a. So the cos double angle can be written in one of these 3 formats, any one of them. And they have given us this one this time. But it could have been this one. No, that's a plus. Can be plus. That's to be a minus. All right. It is that. And see, this is a plus right here. Has to be a minus. See, looks like this, you know. It has to be a minus. So the correct answer is right here. All right, let's continue. Soon finish. This one says dang. And for this, we satisfy this equation R. So this could be on a paper 2, you know. That question could be on a paper 2 to solve. We want to change this into sine. So let's write it over here. 2 cos squared x plus 3 sine x equals 0. That's a paper 2 question. We're going to use the identity that says, see, we can't change this, you know, but we can change this and make it into a quadratic in sine. We're going to use cos squared x equals 1 minus sine squared x. Well, this is 2 of them. So 2 of this equals 2 of this minus 2 of that. So I'm going to replace this with this. And I'm going to get 2 minus 2 sine squared x plus 3 sine x equals 0. This is a paper 2 question. That's what this becomes. Make this positive. Multiply 2 by minus 1. When you're doing quadratics, it's easier when the square term is positive. Multiply this by a minus 1, we get 2 sine squared x. Multiply this by a minus 1, it becomes minus 3 sine x. Multiply this by a minus 1, it becomes minus 2 equal. Multiply this by a minus 1, it stays 0. Yeah, factorize this. Bam, bam, bam. Equals 0. 2 sine x, sine x, sine x. I have to put the 2 with the 2 to get 4 minus 1 to give me 3. I have to put the 2 over here and the 1 there. Signs are different. Get the greater product, the minus sign. The greater product is the far product. Make it negative, positive here. So I'm getting sine x equals minus half from this. I'm getting sine x equals 2 from this. This is not valid. This is not valid. Sine cannot be greater than 1 or less than negative 1. So this is not valid. So I'm only now solving this. How do we solve that? That means we want sine where sine is negative. Sine is positive here and here, and so it is negative here and there. Principal angle for a half is sine to the minus 1 of the positive value. The principal angle alpha is sine to the minus 1 of a half, which is 30 degrees. 30 degrees is pi by 6. So what the equivalent of pi by 6 in here is pi minus pi by 6. Equivalent of pi by 6, pi minus pi by 6. Equivalent of pi by 6 in here is 2 pi minus pi by 6. This is the same as 6 over 6 minus 1 over 6. That's 5 pi by 6. 5 pi by 6. That's a 5 pi by 6. That's a 5 pi by 6. And that's a 5 pi by 6. And then this one, so you see something is wrong. Oh, I want to write negative, my mistake. I want to write negative. So I want this quadrant, my mistake. I want to write negative. So I want this quadrant, which is pi plus pi by 6. And this is 6 over 6. So it's 7 pi by 6. Good. So it's 7 pi by 6 and 11 pi by 6, which is this one. 7 pi by 6. It's going to be 11 because it's the same as 12 over 6. 12 over 6. 12 minus 1 is 11. So that is it, these two. This could be a paper 2 question, guys. That's a paper 2 question. All right, that's a paper 2 question. Number 30, we're almost there. This question says, calculate the area of the sector. The area of the sector. The angle is pi by, that's 90 degrees, you know. Pi by 2 is 90 degrees and radius is 4. That's it. So it's not drawn to scale. Radius is 4, angle is pi is 90 degrees. So it's half r squared theta. So it's half 4 squared times pi by 2. So that is 16 over 4 is 4. So it's 4 pi. And so it's 4 pi. That could be on a paper 2 as well. Half r squared theta. Half r squared theta is the area. Next question. We have to differentiate this. Composite function. Come inside, please. Differentiate this as a whole first. As if it was x cubed first, right? So it's to become 3 times 3x minus 2 squared. We have to also multiply by the difference of what's in the bracket. When you differentiate in there, you're going to get 3. So you're going to get this answer down here. But the 3 3's is 9. So you're going to get this as the answer. Don't give it away. That's it. Next one. Quotient. Differentiating a quotient. Remember, when differentiating a quotient, start with the bottom and end with the bottom squared. So I'm looking for the one that starts with the bottom. This one starts with the bottom and this one starts with the bottom. So I know that answer is one of these two. And it ends with the bottom squared. But this one ends with the bottom squared as well. So I'm going to check now. See, this is our plus. This is the one with the minus. Bam. Answer is this one right here. Answer is this one right here. See? Start with the bottom. So the bottom here. My focus is on the bottom. Start with the bottom. Start to the bottom, end with the bottom square. And then you have a minus up here. This one is a plus, wrong. All right, so the answer is that one. Easy, easy, easy. That's the answer. So it's the bottom. And then differentiate the top. When you differentiate the top, you get the 3. Then you minus the top. See, you minus in the top. And then you differentiate the bottom. You differentiate in this bottom to get that. And you divide by the bottom square. That is it. So this is the answer. You can fast, nice and easy. When you know your stuff, these things are easy, easy, easy. Next one. You want us, given that, they give us this. They say I must find dy by dx at the point x equal pi by 3. So we differentiate this first. So dy by dx first would be, when you differentiate sine, you get cos. So you're going to get 3 cos x. Differentiate the 2, you're going to get 0. They're plugging in pi by 3 in here. Pi by 3 is 60 degrees, you know. Cos of 60 degrees is a half. So it becomes 3 times the cos of pi by 3. Cos of pi by 3 is a half. So it becomes 3 times a half, which is 3 over 2. Easy questions. Cos of pi by 3. Pi by 3 is 60 degrees. Cos of 60 degrees is a half. More things you know, easier the exam is. This question says this point lies on this curve. This could be a paper 2 as well. The equation of the normal. I want the equation of the normal. So I have to work it out. This could be a paper 2 question as well. I'm going to expand this out into separate terms first. Y equals x into x squared minus 6x plus 9. When I expand this, then it becomes y equals x cubed minus 6x squared plus 9x. I want the normal. Remember, when you have a curve, tangent is your better friend. Tangent is a better friend than the normal. The grade of a tangent is dy by dx, which is 3x squared minus 12x plus 9. You want at the point where x equals 2. At x equals 2, the gradient of a tangent becomes 2 here, so give me 12, minus 2 here, so give me 24, plus 9. So the gradient of a tangent is negative 3. That's negative 12 plus 9 is negative 3. So the gradient of the normal is a negative reciprocal of that, which is a third, and we're using the point 2, 2. So it becomes y minus 2 equal the gradient of the normal into x minus 2. Which one of them is that? Right here. Done. Soft. The capital T. Let's go. Number 35. An object moving a straight line so that its velocity is this. Write an expression for the acceleration, but differentiate it. Differentiate it for the expression for the acceleration. Differentiate it. So there's a multiplying constant. So the acceleration is dv by dt equals. That's a multiplying constant. It doesn't change. Stays there. Differentiate the t squared, I get 2t. Differentiate the minus 60, I get minus 6. And then I can expand this. So I get 4t minus 12. 4t minus 12. Done. Easy stuff. Next one. Positive value of z such that this equals 9. This equals 9. So I have to work this out and equate it to 9. First, we're going to integrate this. We're going to get x cubed over 3 between z and 0 equals 9. All right. So I'm going to plug in the z first. I'm going to get z cubed over 3 minus plug in the 0. I'm going to get 0 equals 9. So z cubed equals 27. So the z has to be 3 because 3 cubed is 27. So the z has to be 3. Argument done. The z has to be 3. That's number 36. Number 37, we're getting there. Number 37. dy by dx equal to that. What is y? Integrating. I have to concentrate now. When you differentiate sine and get cos. Now when you differentiate cos, you get sine. So integrate sine, you're gonna get minus cos. So this is gonna give me, this is gonna give me minus 3 cos x. When you differentiate cos, when you differentiate sine, you get cos. So you integrate cos, you get back sine. So this is gonna become minus 2 sine x plus c. So I'm looking for this answer now. Boom, bang, boom, bang. One of them are 2 negatives. 2 negatives. See it right here, so 2 negatives in there. That's it. Done. Easy. Number 38. Finite region R bounded by the y-axis, x-axis, and the R curve shown in the diagram. What is the area? What is this area R? It becomes the integral of this between 0. This could be a paper 2 as well. This could be a paper 2. All right. So the area becomes, let's use the blue ink. The area is the integral of y dx between 0 and 3. See, between 0 and 3. Talking about this area right here. So, and this is the curve. This is the curve. So it's the integral between 0 and 3 of x minus 3 squared dx. What happened to this? You can integrate this as a composite, you know, it becomes equal to, treat it as if it is x squared first. It becomes x minus 3 cubed divided by the cube, and here divided by the difference of what's in here, which is 1. No impact. And going between 3 and 0. Don't assume that that 0 gives a 0. To simplify this, I'm going to multiply out this 3 out here first as a third. I'll factor it out. I'm going to get a third into x minus 3 cubed between 3 and 0. Let's go. Equals. Plug in the 3 first. I get a third into, plug in the 3 first. I'm gonna get 0. I'm gonna get 0 cubed minus, plug in the 0 now. I'm gonna get minus 3 cubed. All this work now. I'm gonna get a third. This become negative 27. Negative that, I get a positive 27 in the bracket. 27. A third of 27 is this 9 right here. 9. Third of 27 is 9. Number 39 says the velocity v as a particle moving from rest is given by that. The displacement at t equals 3 is what? Now, this question says a particle velocity v moving from rest. Moving from rest. If moving from rest, it means when t equals 0, the velocity is 0, and moving from rest. This could be a paper 2 question again. The displacement is the integral of this velocity, which is 6t squared minus 4t plus 3. So when you integrate that, you're gonna get, add 1 to this power divided by a new power, I'm gonna get 2t cubed. Add 1 to this power, I get a 2 divided by 2, I'm gonna get 2t squared plus 3t plus c. But this c is 0 because of this. When t equals 0, v equals 0. So this c is 0, so I don't need to put it. And I want us to tell them the displacement when t equals 3. So all I have to do now is plug the 3 in here. Yeah, displacement when t equals 3. So when t equals 3, the s becomes, put 3 inside this, I get 3 cubed is 27. 27 times 2 is 54. Put 3 inside this, I get 3 squared is 9. 9 2 is 18. Put 3 inside this, so I'm gonna add 9. 3 3 is 9. This give me 9 minus 9. 54 minus 9 is how much? 54 minus 9, is that 45?
Yes, sir.
Oh, that is the answer, 45. Coming to an end now. Coming close to an end now. This one wants me to integrate this. Easy stuff. That's a composite. First, integrate it as if it is x to the 5th power. So I'm going to get 2x plus 3 to the new power of 6. Add 1 to the power, I'm going to get power of 6. Divide by the new power of 6. And divide by the differential inside, which is this 2. Divide by this 2. I have to remember that. Plus c. Don't forget the plus c. All right, so this is something over 12, right? Over 12. This is 12. Boom, bang. This is the expression over 12. This is 12 on a year. Plenty of people forget to divide by that 2 and get it wrong. So it looks like this one right here. That is it. Over 12 plus c. All right, that is that. Next one. Statistics. This one says the number of children in a family is shown table below. This is the number of children, number of families. So 9 families have 0, 10 families have 1, 12 families have 2. All right, the mean number of children per family. So we have to work it out. The mean number of children, we have to just work it out. So it's 9 times 1. How many families? We have to add up the number of families, right? Per family, so the number of children. So this basically want, see this number of children per family means that you want the total number of children divided by the total number of families. That's what you want. So the total number of children is 9 times 0, which is 0. 10 times 1, which is 10. 12 times 2, which is 24. 7 times 3, 7 family of 3, which is 21. And let me shift this over. The total number of families over the number of children or number of families. I'm calculating the number of children first. 2 families have 4, so that is 8. That's the total number of children. I have to divide by the number of families. These are the number of families. How many families there? 9 plus 10 plus 12 plus 7 plus 2. Somebody wrote that out for me. This up here, so it's 34. Write this out for me now, please. Add up that and that over that and tell me what you get. What I get?
The answer is A.
A. All right. So everybody understand the statement, right? Number of children per family. So we calculate the total number of children and put them over the total number of families. That's all you have to do. This is the total number of children, because 9 families have 0 children. 10 families have 1 child. So that's 10 children right there. 12 families have 2, so that's 24. That's 24 right here. 7 families have 3 each. So that's 7 3 is 21. 2 families have 4 each. So that's 8 more children. That's 8 more children out here. These are the total number of children, and they add up the number of families under there. Because you want the number of children. You want the number of children per family. So you put the total number of children over the total number of. It says B is the answer, you say? Or E? A.
A.
All right, good. That's number 1, 41. So we'll get into the finish line now. Get into the finish line. This question. This is a box and whisker plot. It said the shape of the distribution of the population is negative skewed. So the box along on the left side, negatively skewed, negatively skewed, negatively skewed, 3 only. So the answer is just right here. Easy question, negatively skewed. So the probability of an event occurring is 0.3, and probability of an event B occurring is 0.6. Given that the two events are independent, what is this equal to? If they're independent, the probability of A given that B has occurred will be equal to the probability of A. So the answer is the probability of A, which is 0.3. Soft. So this question is testing your knowledge of this rule. The events are independent, then the probability of A given that B has occurred will be equal to the probability of A, which is 0.3. Easy question, all right? Done. Number 44, almost there. This question is testing our probability equation formula. This and this must add up. Them two here must add up and equal them two there. So it means that this thing equals 0, equals 0. See? Them equals 0. Because this already is 0.5 and them here is 0.5. In addition to that, they say they are mutually exclusive events. So the mutually exclusive, it means there's a two non-intersecting sets. There's no intersection. So probability of an intersection, there's no intersection, is 0. So whether you want to look at it from the theory of the mutually exclusive events, that there's no intersection, so the intersection is 0, or you want to use the probability formula that the sum of these is 0.5 must equal the sum of these, and this is already 0.5, so this must be 0. So whichever way you want to look at it, the answer is that 0. And then we are at the last question. What time is it now, Kai? So it took about 45 minutes to do it. See, not too long. Next question. In a class of 50 students, that's a sets question, guy. Want to see that? Set up your sets. Not complicated. Set up your set. A class of 50 students, set up your Venn diagram. 50 students out here. In a class of 50 students. 25 study chemistry, 20 study chemistry, chemistry and physics, chemistry and physics. 20 study chemistry, let's put on the figures. So 20 is in chemistry. So it means that this and this must add up to 20. 25 study physics, so it's a 25. So it means that here and here must add up to 25. What did it say? And it said, and let me read it again. 20 study chemistry, 25 study physics, and 10 study both. So inside the start 10. Inside the start 10. Easy question. Inside the start 10. So if inside the start 10, then write the start 10 too. And this are 25, then write the start 50. Now these add up right now too much. These add up to 35. Everybody is 50. So all just must be 15. 15 not to the none. It's a the probability that a student study neither. That's 15 out here out of the 50 students. 15 out of 50. Bang. Very good?
Yes, sir.
Yes, sir.
Yes, sir.
That's a CSEC question. CSEC. CSEC question. So when you get a question, you can set up a Venn diagram, set it up and just put in the values. You can fast, nice and easy. And that is that. Very good?
Yes,
But
sir.
okay, right. If you have any questions, you can send them to me individually, no problem. But that is the end of this revision, guys. I hope you will crush that exam tomorrow. It's gonna be soft. Promise you. It's gonna be soft. All right. So let's go there, relax, and just do your best work. Okay.
Yes, sir.
Yes, sir. Thanks.
All right. All right. So good night. Get some good sleep. Make sure you're well rested. So if I have one small question you want to send for me, no problem. I'll see if I can answer it for you. Okay. All right. Good night. I'm going to end this.
Yes, sir. Thank you. Good night.
Good night, sir.
Bye,
Thank you.
everybody. You're welcome. Bye, everybody. Good night.
Later, sir.
All right. Bye-bye. And fun. Cool. Miss Tess. Tess gone. Just jump off quick. All right, that is that.